Hello and welcome to The Sleepy Scientist, and thank you for joining tonight. This is your time to unwind, to settle into the quiet, and to let your mind drift at the pace of the planets themselves. Tonight's journey takes us to Venus, the world that so often shines in our skies as the bright morning or evening star, yet hides behind thick clouds, a realm that is as strange as it is fascinating. Before we drift too far into the clouds of Venus, I would love to know, where are you listening from? A quiet city apartment, a countryside home, or maybe somewhere in between? It's always wonderful to see how far these journeys travel across our own Earth. If this gentle voyage helps you relax, please do leave a like and consider subscribing for more calm explorations of science and space. To those who are already subscribed, thank you so much for being part of this community. It means the world. And if you'd like to be gently reminded when the next story's ready, tap the little bell so you won't miss a new upload. Now, I should offer a small warning. I hope the video isn't so interesting that it keeps you awake, but if it does, at least your dreams might be filled with volcanic mountains, swirling clouds, and the mysteries of a world both near and impossibly distant. So, what is it that makes Venus both our planet's twin and its most twisted reflection? Let's begin. Venus is often called Earth's sister, a planet born from the same swirling cloud of dust and gas, orbiting close to us in the same solar neighbourhood. On paper, it should have been a familiar world, almost the same size, made of the same basic ingredients, and with a similar position in the Sun's gentle habitable zone. And yet, what became of Venus could hardly be more different. When we look at Venus from Earth, it dazzles like a jewel. It is brighter than every star in the night sky, second only to the moon in brilliance. It has inspired myths of goddesses, love and light, but behind that shining mask lies a planet that pushes the extremes of what a world can be. Where Earth has oceans, Venus has vast plains of basalt. Where Earth has blue skies, Venus has a heavy shroud of carbon dioxide and clouds of sulfuric acid. Where Earth has winds and rains that nourish life, Venus has storms that race around the planet at hurricane speeds and heat that never fades. For centuries, Venus has tempted us with questions. Could life ever have existed there? Did it once have oceans that boiled away under a runaway greenhouse effect? Is its surface still alive with volcanoes, hidden beneath the veil of clouds? These questions have drawn spacecraft across the void, from the daring landers of the Soviet Venera program to the radar eyes of NASA's Magellan probe. Venus also holds a mirror to us. It shows what happens when a planet's climate tips too far, when balance is lost. Some scientists believe that billions of years ago, Venus may have been more Earth-like, with a gentler atmosphere and even liquid water. But while Earth nurtured life, Venus became a cautionary tale, a furnace sealed in its own heat. And yet, it is not just the extremes that matter. There is a strange beauty to Venus, a kind of alien poetry in its endless clouds, in its slow backward spin, in its role as the brightest wanderer of our skies. It reminds us that even among worlds born as twins, destiny can diverge wildly. As we explore Venus, we will step carefully through its mysteries, its atmosphere, its surface, its storms, and its history, both in science and in myth. Along the way, we will uncover not just what makes Venus unique, but also what it can teach us about our own fragile home. So let us drift now, gently, into the thick yellow clouds of Earth's twisted twin, and ask, what secrets lie beneath the veil? In the beginning, long before there were names, myths, or even an Earth to name them from, the solar system was a restless nursery. Clouds of gas and dust swirled around a young sun, clumping, colliding, and slowly shaping themselves into the familiar worlds we know today. Out of that turbulent disk of matter came two planets so similar in size, in mass, and in composition that it is hard not to think of them as siblings. One of those would become the Earth beneath your feet, and the other would become the strange, brilliant, and forbidding world of Venus. When you picture those earliest times, Imagine not an orderly system of planets, but rather a cosmic demolition derby. Chunks of rock the size of cities were colliding daily, smashing together with enough energy to melt stone and spray molten debris across space. Some objects were swallowed up by the growing planets, others were flung out into the cold reaches beyond the sun's light. For tens of millions of years this was the background noise of creation, violence on a scale we can barely comprehend, but one that was essential to forming stable worlds. Venus and Earth emerge from this chaos as near twins. Both are rocky planets, made of the same basic elements, silicates forming their crusts, iron making up their cores. Both grew to almost the same size. Earth just slightly larger, but only by a narrow margin. Venus has about 90% of Earth's mass and almost the same diameter, so close that if you were holding models of the two planets in your hands, you would struggle to tell which one was the bigger. This is why astronomers call Venus Earth's twin. The resemblance is not perfect, of course, but the similarities are striking enough that they stand out from the rest of the solar family. The reason Venus and Earth ended up so similar lies in their birthplaces. They formed close together in the solar system's so-called habitable zone, the band around the Sun where conditions are just right for liquid water. Slight differences in orbit meant that Venus circled a bit closer to the Sun, while Earth stayed slightly farther out. But in the early years, both planets were still in positions where they could have shared many of the same starting ingredients: water, carbon, nitrogen, and other building blocks of life. It is no surprise then that scientists often wonder what Venus might have looked like billions of years ago. Could it once have had oceans like Earth? Could it have been a truly habitable twin before its fate diverged? In those early days, both planets were subjected to heavy bombardment. Asteroids and comets delivered not only destruction, but also gifts. Many researchers believe that water arrived this way, carried inside icy rocks from the outer regions of the solar system. Picture massive comets slamming into the young Venus and Earth, vaporizing on impact, and leaving behind water molecules that eventually gathered into oceans, lakes, and seas. We cannot know for certain how much water Venus originally received, but evidence suggests it may have once had quite a bit, enough that oceans could have covered much of its surface. If that is true, then the image of Venus as a dry, searing desert is only part of its long story. The story of siblings in space is not unique to Venus and Earth. Mars, smaller and more distant, is often described as a cousin, another rocky planet that seems familiar but different. Mercury, the smallest of the inner planets, is more like a wayward relative, stripped down to an iron core by violent impacts or the sun's searing heat. But among all these worlds, Venus stands out. It is not just similar to Earth in size, it also shares a comparable density and composition. If you could somehow lift Venus and Earth onto a cosmic scale, you would see that they are balanced almost evenly. Yet being twins does not mean being identical. Anyone with a sibling knows that. From the very beginning, Venus's slight closeness to the Sun may have given it a different trajectory. Just a few million kilometers closer to the furnace of our star might not sound like much, but it was enough to set the stage for a world where conditions could easily tip from stable to extreme. The difference between a comfortable greenhouse and a runaway greenhouse is, after all, a delicate one. To understand why Venus became Earth's twin in name but not in nature, it helps to linger on the image of that early solar system. Imagine molten surfaces glowing red as they cooled, vast seas of lava slowly hardening into crust. Both Earth and Venus would have gone through this fiery adolescence, their atmospheres thick with volcanic gases. As they stabilized, their similarities must have been astonishing. Two planets of nearly equal stature, with the potential to grow into fertile, dynamic worlds. From afar, they might have looked like twins dressed in the same colors, ready for lives that could have unfolded in parallel. Venus is also called Earth's twin because of the way it shines in our sky. It reflects sunlight with dazzling brilliance, often mistaken by casual observers for a star. That brightness is part of what made ancient cultures so attentive to it, weaving it into stories and legends. It was easy to think of Venus as a counterpart to the moon, a guiding light that mirrored something of ourselves back to us. The science of its twinship, its size, its mass, its density, would only come much later when telescopes and mathematics revealed how much it truly resembled our home planet. But the intuition was there from the start. Venus feels like something familiar, and familiarity is what we humans grasp at when looking into the night. If you hold on to that image of Venus as a sibling, it helps to frame everything that follows. Twins can share origins, but their paths can diverge wildly. In one, you see oceans, forests, and life. In the other, you find volcanic plains, crushing pressure, and heat so intense it defies imagination. The story of Venus and Earth is a story of how similar beginnings can lead to radically different endings, and how fragile the balance of habitability really is. So, when astronomers call Venus Earth's twin, they are not exaggerating. They are pointing to a relationship that is written in the very numbers that define the planets, their diameters, their densities, their positions in the solar system. Venus is the sister planet that could have been a second Earth, a reminder that chance and circumstance matter deeply in the making of worlds. Looking at Venus is a little like looking in a mirror and seeing not yourself but an alternate version, shaped by just a few small differences at birth. It is that reflection, familiar, yet hauntingly altered, that has made Venus a source of both wonder and caution since the day we first lifted our eyes to the sky. If you're enjoying this gentle voyage to Venus, Earth's mysterious twin, you'll love the rest of our Sleepy Planet series, a soothing exploration of every world in our solar system. New episodes release each week and join the playlist, letting you drift from planet to planet, uncovering the beauty, mystery, and calm that fill the spaces between the stars. Look up on a clear evening just after the sun has dipped below the horizon, and you may notice a light so brilliant that it seems to outshine every star. That light is not a star at all, but Venus, the brightest planet in our sky. Its radiance is so intense that it can even cast faint shadows on a moonless night, and under the right conditions it can be spotted during the day if you know exactly where to look. This dazzling brightness has always set Venus apart, making it a familiar presence for anyone who spends time gazing at the heavens. The reason Venus appears so bright is not a trick of distance alone. Mercury, after all, is closer to the Sun, and Mars often comes nearer to Earth. But Venus wears a cloak of thick clouds that reflect sunlight with remarkable efficiency. Those clouds act like a cosmic mirror, scattering sunlight back toward us, and giving Venus a visual presence far greater than its actual size would suggest. To the naked eye, it simply looks like a jewel pinned against the fading blue or the velvet black of night. It is no wonder that ancient people gave it names and wove it into myths long before telescopes revealed its true nature. For observers on Earth, Venus follows a curious pattern. It never strays far from the sun in the sky. Because of this, you will never find Venus high overhead at midnight. Instead, it appears either in the western sky just after sunset or in the eastern sky just before sunrise. This has given Venus two enduring identities, the evening star and the morning star. When it lingers in twilight after the sun has set, it seems to escort the day into night. When it rises before the dawn, it seems to herald the coming of daylight. In both roles, Venus has been seen as a messenger, a guide, and sometimes even a trickster, appearing and vanishing with predictable but mysterious rhythm. That rhythm comes from the dance of orbits. Venus circles the Sun in about 225 Earth days, but from our perspective it alternates between trailing behind the Sun and racing ahead of it. When Venus is west of the Sun, we see it in the morning sky before sunrise. When it swings east of the Sun, it appears in the evening sky after sunset. Its brilliance makes it one of the first stars to appear in the twilight, and one of the last to vanish when daylight takes over. Entire civilizations once watched these appearances closely, using them as markers of time, omens of change, or signs from the heavens. In ancient Mesopotamia, Venus was associated with Inanna or Ishtar, goddesses of love, fertility, and war. The duality of Venus as both morning star and evening star mirrored the duality of those deities, bringers of life and also of conflict. Babylonian astronomers tracked Venus with meticulous care, noting its cycles and predicting its appearances with impressive accuracy. Their records show that Venus was not just a point of light, but a celestial personality woven into the fabric of their culture. The Greeks and Romans carried this tradition forward, though with their own interpretations. To them, Venus was Aphrodite, goddess of love and beauty, whose brightness and constancy reflected divine presence. The Romans gave the planet the name we still use today, linking it forever to ideals of charm, attraction, and allure. And yet, even among these associations with beauty, the ancient world knew there was something deceptive about the planet's shifting appearances. Some early thinkers even believed the morning star and the evening star were two entirely different bodies, only later realizing they were one and the same. For the Maya, Venus was far more than a beautiful ornament in the sky. It played a role in calendars, rituals, and even warfare. The Maya tracked Venus with extraordinary precision, recording its cycles in the Dresden Codex. They believed its appearances could influence human affairs, and some battles were planned to coincide with its rising. For them, Venus was a powerful cosmic influence, not merely a pretty light. The accuracy of their Venus tables is astonishing, proof of how carefully they observed its movements. In cultures as far apart as Polynesia and North America, Venus was also significant. Navigators used it as a guide across oceans, while storytellers wove it into myths about ancestors and spirits. The universality of Venus is striking. No matter where humans settled, they could not ignore this dazzling wanderer. Its steady brilliance gave reassurance, its shifting roles sparked curiosity, and its predictability offered a sense of order in a chaotic world. Even today, Venus has a way of catching us off guard. Someone walking at dusk might glance up and mistake it for a passing aircraft, its steady glow seeming too bright for a planet. Amateur astronomers often choose Venus as one of their first targets, only to find that through a telescope it does not look like a star at all, but a small disk with changing phases, much like the Moon. These phases occur because Venus, like the Moon, reflects sunlight toward us from different angles as it moves around the Sun. When it is on the far side of the Sun, it appears nearly full. When it swings closer to Earth, it shows a slender crescent, a delicate reminder that appearances in the sky are a matter of perspective. There is something soothing in knowing that this cycle continues without fail. Venus will always return as morning star and evening star, keeping time on a cosmic scale that is both ancient and yet ever new. Our ancestors marked their lives by its rise and fall, and in a quiet way we still do. Farmers once watched for Venus in the dawn sky as a seasonal marker. Poets invoked it as a symbol of longing or renewal. Even in modern times, Venus appears in songs, literature, and metaphors of love and mystery. But beyond myth and metaphor, the sight of Venus has a simple human effect. It draws the eye upward. It asks us to pause for a moment in the bustle of daily life and notice the vastness of the sky. Its brilliance is a reminder that the universe is always present, even if most of the time we're too distracted to notice. There is comfort in knowing that long before telescopes, before science, before history as we record it, people were already watching Venus and feeling that same quiet sense of awe. When you next find yourself outdoors at twilight, try looking to the west after sunset or to the east before dawn. The brightest light you see will almost certainly be Venus, and in that simple act, looking at a planet shining across the void, you will be sharing in a tradition older than writing, older than cities, older than nearly everything we think of as civilization. It is the same light that guided sailors, inspired myths, and stirred questions that science is still answering today. Venus in the night sky is more than a planet. It is a bridge between past and present, between myth and science, between wonder and understanding. If you were to drift downward through the shining clouds of Venus, the view would quickly change from dazzling beauty to suffocating hostility. At first, from orbit, the planet looks wrapped in a smooth blanket of white and pale yellow, featureless except for subtle swirls. But descend into those clouds, and you would find yourself surrounded by thick layers of carbon dioxide, laced with droplets of sulfuric acid. The sunlight above becomes filtered and broken, creating an eerie orange glow. By the time you reach the surface, the pressure would be 90 times greater than what you feel on Earth, and the heat would climb past 460 degrees Celsius, hot enough to melt lead. It is a world that greets visitors with a slow, crushing embrace. The heart of the mystery lies in the atmosphere itself. Nearly all of it is carbon dioxide, over 96% in fact. The rest is a mix of nitrogen and trace gases, but carbon dioxide dominates in a way unlike anywhere else in the solar system. On Earth, carbon dioxide is a tiny fraction of our air, measured in mere parts per million. Yet on Venus, it has become the very essence of the atmosphere, a thick soup that traps heat with ruthless efficiency. This difference alone explains much of why Venus is so hostile while Earth remains habitable. The clouds add another layer to the story. Suspended in the Venusian skies are countless droplets of sulfuric acid formed from volcanic gases and chemical reactions high in the atmosphere. These clouds reflect sunlight brilliantly, which is why Venus shines so brightly in our sky. But beneath that mirror-like layer, the atmosphere acts like a thermal blanket, letting light in but refusing to let heat escape. It is a classic greenhouse effect, but on a planetary scale and taken to its extreme conclusion. To understand the greenhouse effect, imagine sitting in a car on a sunny day. Sunlight pours in through the windows, warming the interior. But the heat does not escape easily, and soon the car becomes uncomfortably hot. Now, imagine the same process, but with an entire planet trapped inside the car. That is Venus. Energy from the sun enters through the cloud tops, is absorbed by the ground, and then radiates back upward as infrared heat. But instead of escaping into space, that heat is absorbed and re-radiated by the carbon dioxide-rich atmosphere, bouncing around until the entire planet reaches a sweltering equilibrium. What makes Venus's situation so extreme is the feedback loop. At some point in its history, Venus may have had water, but as the planet warmed, oceans evaporated into the atmosphere. Water vapor is itself a powerful greenhouse gas, which trapped more heat, causing even more water to evaporate. The cycle fed on itself until every trace of surface water was lost. Once the oceans were gone, the planet had no way to draw carbon dioxide out of the air, because on Earth, much of our carbon dioxide is absorbed into oceans and locked away in rocks. Venus lost that stabilizing mechanism, and the carbon dioxide piled higher and higher into the sky. The result is a surface hotter than Mercury's, even though Venus is almost twice as far from the Sun. Mercury has no atmosphere to speak of, so heat comes and goes freely. Venus, on the other hand, holds on to every scrap of warmth, day and night, across the entire globe. That is why the temperature on Venus does not vary much between poles and equator, or between night and day. Everywhere you go, the furnace is on full blast all the time. It is worth pausing to ask why Earth avoided this fate. After all, the two planets started with so much in common. Part of the answer is distance. Earth orbits just far enough from the Sun that its surface temperature allowed liquid water to remain stable for billions of years. Those oceans acted as a climate regulator, absorbing carbon dioxide from the air, dissolving it, and eventually locking it into carbonate rocks on the seafloor. Life played its role too. Plants and microbes helped cycle carbon, creating oxygen and maintaining a delicate balance. Plate tectonics also makes a difference. On Earth, moving plates recycle carbon between the surface and the interior. Volcanoes release it, while weathering and ocean processes draw it down. Over geological timescales, this system has prevented carbon dioxide from spiraling out of control. Venus, with its immobile crust, may never have had that safety valve. Once its climate tipped toward heat, there was no mechanism to bring it back. Another factor is the Sun itself. Billions of years ago, the Sun was dimmer, giving Venus more breathing room. But as the Sun slowly brightened, Venus crossed a threshold beyond which stability was impossible. Earth remains just outside that danger zone for now. Our planet sits in the habitable zone, but only just, and scientists sometimes describe Earth as living on the inner edge of safety. Venus shows us what happens when that edge is crossed. The chemistry of Venus's atmosphere also creates strange weather. Clouds of sulfuric acid swirl at high altitudes, carried by winds that race around the planet in just 4 Earth days. These upper clouds are surprisingly cool compared to the furnace below, but they're far from friendly. If you could float in them, you would be bathed in corrosive acid mist. Occasionally, these clouds rain sulfuric acid droplets downward, but before they can reach the ground, the heat evaporates them, creating a cycle of acid rain that never quite lands. It is a bizarre twist, a planet where it rains, but the rain never touches the soil. Lightning may crackle within these clouds as well, though it is hard to detect. Some spacecraft have picked up signals that suggest electrical storms flicker across the sky, though others remain uncertain. If true, it means Venus has another way of discharging its immense atmospheric energy, echoing thunderstorms on Earth, but in a far harsher environment. Despite its dangers, Venus's atmosphere fascinates scientists because it holds clues to both planetary history and our own future. The runaway greenhouse effect is a stark warning about the power of atmospheric change. On Earth, small increases in greenhouse gases cause measurable warming. On Venus, the effect was allowed to run unchecked, producing a world that is utterly unrecognizable compared to its twin. The lesson is sobering. The balance of climate is fragile, and once lost, it can be nearly impossible to restore. And yet Venus's atmosphere is not only a warning, but also an opportunity. It is a natural laboratory for studying how atmospheres behave under extreme conditions. By sending probes into its clouds and studying its chemistry from afar, scientists can refine their models of climate and apply those lessons to Earth. In this way, Venus, though uninhabitable, becomes a silent partner in understanding the forces that shape habitable worlds. So when we call the atmosphere of Venus mysterious, it is not just because it hides the surface beneath a permanent veil of clouds. It is because it represents both a past we can only imagine and a future we must strive to avoid. It is at once a cloak of beauty and a curtain of fire, a reminder that even twin planets can tell very different stories. Venus, with its endless carbon dioxide and its sulfuric haze, is a vision of what can happen when a world tips too far. And in that vision lies not only mystery, but also a reflection of our own fragile balance back here on Earth. Imagine for a moment that you could somehow descend through the clouds of Venus, protected from the searing heat and acid rain. As you approach the surface, one of the first things you would notice is not just the temperature, but the weight of the air itself pressing in on you from every direction. On Earth, we are used to an atmosphere that is comfortable, light enough to let us breathe and heavy enough to keep oceans and weather in place. On Venus, that same concept has been taken to an extreme. The pressure at the surface is about 90 times greater than what you feel at sea level here on Earth. To put that into perspective, it would be the same as standing a full kilometre beneath the ocean on Earth, with the weight of all that water pressing down. This staggering pressure is one of the most alien features of Venus. If you or I were to stand there unprotected, it would not be a dramatic explosion or violent tearing apart that ended us. Instead, it would be a slow, crushing inevitability. Your lungs would not be able to expand, your body would be squeezed from all sides, and every bit of air inside you would be forced out. Human beings were never designed to withstand such immense atmospheric weight, and even our most advanced machines struggle to survive in it. The Soviet Venera probes that landed on Venus in the 1970s and 80s were built like deep-sea submersibles. They had to be engineered with thick armour-like shells, and even then the longest any of them managed to survive on the surface was just over 2 hours before the heat and pressure overwhelmed their systems. It is difficult to imagine what such pressure feels like because our lives are so attuned to the relatively gentle weight of Earth's atmosphere. At sea level here, the air presses down with about 1 kilogram per square centimetre. You do not feel it because your body has adapted, pushing back with equal force. But on Venus, that pressure multiplies to 90 kilograms per square centimetre. Every square centimetre of your body would be carrying the equivalent of a person standing on it. Multiply that across your entire frame, and the sensation becomes impossible to bear. It is a reminder that on Venus, even something as simple as the air is not a gift, but a danger. One of the easiest ways to relate to Venusian pressure is through the comparison to Earth's oceans. Divers know that for every 10 meters of depth, the pressure increases by about 1 atmosphere. To experience the conditions of Venus on Earth, you would need to sink to around 900 meters underwater. Few humans have ever descended that far, and those who do rely on submersibles or specialized equipment that can withstand the crushing depths. The idea that on Venus this same force is present not beneath an ocean, but as part of the very air itself, is almost surreal. Instead of open skies and breathable air, the planet's surface is more like a deep abyss where the sky itself is heavy enough to crush. This comparison brings to mind the resilience of life on Earth. In our own oceans, there are creatures that thrive under immense pressure, living happily at depths that would flatten us. On Venus, however, there is no such refuge. The heat and chemistry of the air, combined with its pressure, create conditions that are inhospitable to life as we know it. And yet, considering that extremophils have surprised us time and again on Earth, scientists continue to wonder whether microbial life might exist higher in the Venusian clouds, far above the crushing surface, where the pressure is less severe and the temperatures are more forgiving. From a geological perspective, the high pressure has fascinating consequences. Rocks and minerals behave differently when subjected to such forces. The melting points of substances can shift, chemical reactions can occur more quickly, and the way sound travels changes dramatically. If you could clap your hands on Venus, the sound would not carry as it does here. It would be muffled and strange, distorted by the density of the air. The landscape would feel eerily quiet, not because there is no medium for sound, but because the pressure would swallow it in a heavy, stifling silence. The experience of standing on Venus would also be visually bizarre. The dense atmosphere would scatter and absorb light differently than we are used to, so the sky would appear a murky orange-brown rather than blue. Objects in the distance would be blurred by the thickness of the air, as though you were looking through fog or water. Even the sun itself would appear dim and distorted, its light filtered down until it was just a faint glow struggling to pierce the haze. You would not see a bright star above, but rather a pale disk, robbed of brilliance. Engineers who dream of exploring Venus often describe it as more challenging than Mars, despite Mars being farther away. The red planet is cold, dry and dusty, but its pressure is thin, its climate extreme yet survivable with the right technology. Venus, by contrast, is close enough to tempt exploration, but hostile in every possible way. Heat-resistant alloys, pressure-proof casings and advanced cooling systems are all needed just to last a few hours. Every attempt to reach the surface is like sending a submarine not into water, but into fire. The pressure also affects the way the atmosphere circulates. With such density, winds carry more force, and even modest breezes have the momentum of gale-force winds on Earth. At higher altitudes, winds whip around the planet at hurricane speeds, though near the ground the air moves more sluggishly. Still, every movement of that thick atmosphere adds to the sense of weight, pressing down constantly, a reminder that Venus is not just another planet, but an environment entirely its own. What is striking about Venus is that such pressure is not inevitable. Earth, only slightly farther from the Sun, developed an atmosphere that is far lighter, breathable, and balanced. The difference lies in history and feedback loops. Earth's oceans absorbed carbon dioxide and stabilized our climate. Venus lost its water, and without that buffer, the gas piled up, thickening the air until it became the oppressive blanket it is today. What began as a sibling planet became, through a series of divergences, an alien world where the very sky acts like an ocean pressing down on everything beneath it. When you think of Venus in these terms, it becomes less like a neighbor planet and more like a parallel reality. It shows us what happens when a world tips too far in one direction. Pressure in this case is not just a physical force, it is a symbol of imbalance, of a planet trapped beneath the weight of its own atmosphere. And in that sense, Venus tells us a quiet story of how fine the line can be between habitability and hostility. So if you were ever to stand on Venus, it would not feel like standing on solid ground beneath open skies. It would feel like standing beneath an ocean of air, pressed from all sides, surrounded by heat and silence. The sun, a faint glow above a crushing veil. It is an image both humbling and haunting, a reminder that in the grand family of planets, even near twins can grow into places so utterly different that one becomes a cradle for life and the other a world under unrelenting pressure. If there is one thing we tend to take for granted, it is that planets spin in a certain way. Earth rotates from west to east, giving us a sunrise in the east and a sunset in the west, a rhythm so familiar that it feels universal. But Venus refuses to follow this rule. Instead, it turns backwards, a retrograde rotation that makes its day unlike any other in the solar system. On Venus, the sun rises in the west and sets in the east, a topsy-turvy reversal that leaves astronomers both fascinated and perplexed. The strangeness does not end there. Not only does Venus spin backwards, but it spins so slowly that a single rotation takes 243 Earth days. In other words, one Venusian day is longer than its entire year, which lasts just 225 Earth days. Imagine living on a world where a year passes before you can complete a single spin. Time itself would feel bent out of shape, and the familiar rhythm of day and night would be unrecognizable. Why Venus spins in reverse is still something of a mystery. The leading theories point to the early chaos of the solar system, when giant impacts were commonplace. A massive collision could have knocked Venus off balance, slowing and even reversing its rotation. Another idea suggests that tidal interactions between Venus and the Sun gradually altered its spin, dragging it into this strange state over billions of years. Perhaps it was a combination of both, a colossal impact to start the process, and then the gentle but relentless pull of the Sun to finish it. Whatever the cause, the result is one of the oddest rotations in the solar system. The consequences for sunlight are dramatic. Because of the slow rotation and the thick heat-trapping atmosphere, a single day on Venus is not like the clear cycle we know on Earth. If you stood on the surface, it would take months for the sun to rise, crawl across the sky, and then set. Each moment would be stretched into a slow-motion sequence, as though time itself had grown heavy. Twilight would last for weeks, the glow lingering in the dense air long after the sun dipped below the horizon. Then, when night finally arrived, it would stretch on, almost endless, before the next sunrise came crawling from the opposite direction. This strange rhythm creates a disconnect between Venus's solar day and its actual spin. A solar day, the time from one noon to the next, lasts about 117 Earth days on Venus. This happens because the planet's retrograde spin interacts with its orbit around the Sun, effectively shortening the day-night cycle, even though the rotation itself is longer. The math is peculiar, but the effect is simple. Time on Venus is distorted in a way that defies our usual experience. Days and years lose their familiar meaning, and sunlight behaves in ways that feel alien. Imagine trying to live under such conditions. On Earth, our biology is tied to a 24-hour cycle. Plants open and close their leaves, animals hunt or sleep, and humans build entire societies around the predictable rhythm of day and night. On Venus, with a day that stretches longer than a year, life as we know it would struggle to adapt. Plants would bake for months under relentless sunlight, then freeze in the long, dark night. Animals would find their instincts utterly mismatched to the planet's tempo. The only life that could possibly survive would have to adapt to conditions so extreme that it is difficult for us even to imagine. This backward spin also means that the winds and weather patterns on Venus are shaped in unusual ways. While the surface air moves slowly, high above the clouds, the atmosphere whips around the planet in just 4 Earth days, a phenomenon known as superrotation. From the surface, you might not notice the winds, but above your head the skies would be racing eastward, completing a full circuit while the ground beneath you crawls slowly in the opposite direction. It is as if the atmosphere itself cannot be bothered to wait for the planet's sluggish spin. The retrograde rotation also adds a layer of complexity to how we view Venus from Earth. Observing its phases through a telescope, astronomers noticed that the planet appeared to move across the sky in ways that defied simple expectations. Galileo, when he first saw Venus showing crescent and gibbous phases, realized it must orbit the Sun, not Earth. Centuries later, scientists pieced together that its odd movement and rotation were unlike anything else nearby. Venus became not just a bright ornament in the night sky, but a puzzle in celestial mechanics. There is something almost poetic about a planet that insists on doing things backwards. It serves as a reminder that the universe is not obliged to follow patterns that make sense to us. For every Earth with its comforting 24-hour day, there can be a Venus with a year that slips by faster than a single rotation. And yet, despite this oddity, Venus continues to move in a steady, predictable orbit, keeping time with the rest of the solar system. Its difference is not chaos, but simply another form of order, one we must stretch our minds to comprehend. If you were to stand on Venus and watch the sun rise in the west, you might feel the disorienting sensation of living in a mirror world. The familiar cycle of east to west would be reversed, and every instinct about time and direction would be challenged. It is a thought experiment that makes one appreciate just how much of our sense of order comes from the simple turning of our own world beneath the sun. Venus shows us that even in a family of planets born from the same disk of dust and gas, the details can vary so wildly that one sibling spins comfortably forward while another lingers, backward and slow. In that strangeness lies a deeper lesson. Time, sunlight, day and night, things we take for granted, are not universal constants but fragile arrangements, dependent on the quirks of planetary history. Venus is the twin who chose a different rhythm, a reminder that even in the orderly dance of the cosmos, there is room for worlds that march to their own, peculiar beat. On Venus, heat is not a passing phase of the day, or a seasonal shift, it is a permanent state of being. The surface simmers at an average of about 460 degrees Celsius, a temperature hot enough to melt lead or zinc. There are no cool evenings, no chilly mornings, and certainly no winter reprieve. The planet exists in an eternal furnace, where the concept of weather is not about variations in temperature, but about how that overwhelming heat interacts with the thick atmosphere and restless clouds. If you could stand there, surrounded by jagged volcanic plains and mountains hidden beneath a sulfurous sky, the heat would press against you without mercy. It is startling to realize that Venus is actually farther from the Sun than Mercury, and yet it is hotter. Mercury, being closest to the Sun, might seem like the natural candidate for the hottest world. But Mercury has almost no atmosphere, so while its daytime side does bake in direct sunlight, its nights plunge into extreme cold. The planet cannot hold on to its heat. Venus, on the other hand, has a dense, choking atmosphere of carbon dioxide that traps heat with extraordinary efficiency. Once energy from the sun gets in, it has little chance of escaping. The result is not just a warm climate, but a thermal prison. The greenhouse effect is familiar on Earth, where it keeps the planet's surface from freezing solid. Without it, our world would be an icy ball far less hospitable. But like all good things, there is a balance. On Venus, that balance spiraled out of control. Carbon dioxide makes up more than 96% of the atmosphere, and with such an abundance, the greenhouse effect has gone into overdrive. Heat comes in, but it cannot leave. Even at night, even at the poles, even on mountain peaks, the temperature stays almost the same, unbearably high, unchanging, and indifferent to the rhythms that govern Earth. One of the strangest consequences of this runaway greenhouse effect is how uniform the heat is. On Earth, you can feel the difference between the warmth of the equator and the chill of the poles, or between day and night. Venus erases those distinctions. Because its atmosphere is so dense, heat is distributed evenly across the globe. Winds at high altitudes whip around the planet in just a few Earth days, carrying energy and blending it into a nearly uniform climate. No matter where you go on Venus, the thermometer points to the same impossible number. This unrelenting heat also shapes the geology of the planet. Metals that are solid on Earth would soften or even melt under Venusian conditions. Lead, for instance, would pool into liquid, and zinc would behave the same. Even substances we think of as rugged and dependable would struggle in such a world. The surface rocks themselves glow faintly in infrared, radiating energy that struggles to pierce the carbon dioxide blanket above. It is as though the entire planet is locked inside a slow cooker, sealed shut and turned to its highest setting. The balance that governs planetary temperatures is usually a dance between incoming solar energy and outgoing thermal radiation. On Earth, sunlight warms the ground, which then radiates heat back into space. Venus disrupts this balance. The thick carbon dioxide atmosphere is excellent at absorbing infrared radiation, bouncing it back toward the ground again and again. Each attempt at cooling is met with resistance, and over time the system tips further out of equilibrium. This is thermal balance gone wild, a feedback loop that no natural mechanism has been able to halt. Scientists believe Venus may not always have been this way. In its earliest history, it may have had milder conditions, perhaps even oceans. But as the sun slowly brightened over billions of years, water began to evaporate. Water vapor itself is a greenhouse gas, and as it built up in the atmosphere, it trapped more heat. This heat evaporated more water, which trapped more heat still. Eventually, the oceans boiled away entirely, and Venus was left with a barren surface and an atmosphere dominated by carbon dioxide. Without oceans to absorb carbon, there was nothing to regulate the climate. What might have been a temperate twin of Earth became a permanent inferno. The thought that Venus could once have been more Earth-like is both tantalizing and unsettling. It suggests that planetary habitability is fragile, that a few shifts in distance, composition or timing can lead to radically different outcomes. On Earth, water cycles through oceans, clouds and rocks, helping to moderate our climate. Life itself plays a role in keeping balance, with plants and microbes pulling carbon from the air. Venus, lacking these stabilizing systems, was vulnerable to tipping into its current state. Once the process began, there was no turning back. The permanence of the heat is another sobering fact. Because Venus's atmosphere is so dense and its greenhouse effect so strong, its surface temperature does not fluctuate much over time. Whether in day or night, summer or winter, the environment is locked in place. This constancy is alien to us, accustomed as we are to seasons, cycles, and weather shifts. On Venus, the only rhythm is the endless hum of heat, the ground always glowing, the air always heavy with energy that cannot escape. The human imagination has often turned Venus into a stage for science fiction. Early writers once dreamed it was a jungle world hidden beneath the clouds, steamy and lush. Others imagined vast oceans or strange swamps. When the truth was revealed, it proved more extreme than anyone guessed. Instead of rainforests, there is a desert of volcanic rock. Instead of tropical rain, there are sulfuric acid mists. Instead of steamy warmth, there is a deadly, lead-melting inferno. Reality, in this case, was more dramatic than fiction. And yet, even in its hostility, Venus has a strange beauty. To know that a world can glow like a star in our night sky while hiding such extremes is humbling. It makes Earth's balance of temperature and climate feel all the more precious. The lesson of Venus is not just about science, but about perspective. It shows us that the conditions we take for granted, cool evenings, flowing rivers, snow on mountain peaks, are not universal. They are delicate, the result of finely tuned balances that can be disrupted. So when we speak of the heat on Venus, it is not merely a number on a thermometer. It is a story of imbalance, of a world where thermal equilibrium broke down and never recovered. It is a reminder that in the cosmic lottery of conditions, even twin planets can land on very different fates. Venus, shining so serenely in our skies, is in truth a furnace that never cools, a place where heat is not a passing season, but the very definition of existence. The most striking feature of Venus, even from far away, is its cloak of clouds. Unlike Earth's skies, which break open to reveal blue during the day and stars at night, Venus is forever wrapped in a thick, luminous shroud. These clouds are not made of water vapor as ours are, but of sulfuric acid, one of the harshest substances known to us. Imagine a world where every puff of cloud is laced with acid, where the rain that forms is not refreshing but corrosive, and where even the possibility of seeing a clear horizon is denied. This is the realm of Venus, a world of fire and mist. The sulfuric acid clouds begin high in the atmosphere, forming dense layers that stretch for many kilometers. They are born from chemical reactions between volcanic gases, carbon dioxide, and the relentless ultraviolet light of the sun. Sulfur dioxide rises from the surface through volcanic outgassing, mixes with water vapor, and reacts under solar radiation to create droplets of sulfuric acid. These droplets cluster together, drifting and swirling in vast formations that give Venus its dazzling brightness when seen from Earth. The irony is that the very thing that makes Venus sparkle like a gem in our night sky is the same thing that makes its skies so unforgiving. In these clouds, rain does form, but it is nothing like the nourishing rain of Earth. Sulfuric acid droplets grow heavy and begin to fall, pulled downward toward the surface. For a brief moment, you might imagine the landscape being pelted with acidic rainfall, carving rivers and dissolving rocks. But that image never becomes reality. As the raindrops descend into the lower atmosphere, they meet temperatures so extreme that they evaporate long before reaching the ground. The rain is born in the clouds, begins its descent, and then vanishes into vapor, returning to the cycle above. It is a planet of ghost rain, where droplets endlessly fall and fade, never touching the surface they seem destined for. This process creates a strange kind of precipitation cycle. Unlike Earth, where water completes a loop between sky, ocean, and land, Venus has a cycle that never finishes. Sulfur dioxide rises, acid clouds form, droplets fall, but then the heat swallows them before they arrive. It is like watching a play in which the final act is always cut short, leaving the story suspended in mid-air. The surface of Venus remains dry not because rain never forms, but because rain is never allowed to arrive. For anyone imagining what it would be like to stand on the surface, this reality adds another layer to the planet's already daunting atmosphere. You would never feel rain striking your skin. Instead, you would stand beneath a sky of churning acid clouds that never break. The air would shimmer with a hazy glow, and the landscape would remain untouched by falling water, or acid, forever. The ground itself is so hot that even if a droplet somehow survived the fall, it would flash into vapor the instant it touched the rocks. On Venus, nothing can cool the land. The visual appearance of these clouds is equally unsettling. The dense layers scatter sunlight in strange ways, creating a perpetual golden yellow haze. On Earth, sunlight paints the sky blue because of how our atmosphere scatters shorter wavelengths. On Venus, the thick carbon dioxide atmosphere and sulfuric clouds filter light differently, smothering blues and letting through the longer, warmer colours. The result is an eternal twilight glow that turns the sky into a dim yellow-orange. It is a world locked in a sunset that never ends, but without the relief of night stars to follow. Even the sun itself is transformed by this atmosphere. From the surface, the sun would not blaze with its familiar brilliance. Instead, it would appear as a pale, blurred disk, its rays weakened and distorted by layers upon layers of cloud. Imagine looking upward and seeing only a faint smudge of light, dimmed and scattered, as though the star we depend on for life were nothing more than a hazy lantern behind a curtain. Shadows would be indistinct, light would be diffuse, and the very rhythm of day and night would feel muted, stretched thin through the sulphurous veil. Despite its hostility, the atmosphere of Venus has fascinated scientists for decades, precisely because it is so different from our own. Probes that have entered these clouds have had to withstand not just corrosive chemicals, but violent winds that circle the planet in a matter of days. Instruments are eaten away by acid droplets, their sensors blinded by the density of the haze. Yet these brief glimpses have revealed a world that is both chemically active and strangely stable. The acid clouds may seem destructive, but they are a natural result of the balance Venus has settled into, a balance very different from Earth's, but a balance all the same. There is also a haunting beauty to the thought of endless golden skies. While toxic and uninhabitable, the atmosphere of Venus is visually mesmerizing. Think of a landscape bathed forever in amber light, every horizon blurred by mist, every shadow softened into haze. It is a world of strange aesthetics, beautiful in its danger. The misty veil turns the planet into a giant lantern, glowing back at us through the night sky. That glowing appearance is part of why Venus has always seemed so alluring from afar, like a cosmic beacon, even as its true nature is harsh beyond imagination. Comparisons with Earth make the contrast even sharper. Here, clouds bring water, the lifeblood of ecosystems. They paint our skies with shifting patterns of white, grey and gold, breaking open to reveal deep blues or starry nights. On Venus, clouds are permanent, toxic and unyielding. They do not nourish, they deny. They do not open, they obscure. Instead of life-giving rains, they produce phantom downpours that dissolve back into vapour, leaving the land below barren and burning. It is a reminder that clouds, so familiar to us, can play very different roles on other worlds. For planetary scientists, studying Venus's clouds also offers insights into other planets beyond our solar system. Many exoplanets discovered orbiting distant stars are shrouded in thick atmospheres. Some are super Venuses, worlds larger than our neighbour but with similar runaway greenhouses. By understanding the sulfuric acid mists and perpetual haze of Venus, we gain a glimpse into what these distant planets might be like. Venus, in this way, becomes a key to interpreting the cosmos, its strange weather teaching us how common or rare habitable climates might be. So when you picture Venus, it is worth remembering that beneath its jewel-like glow lies a sky unlike any other. Clouds of acid drift endlessly, rains vanish before they fall, and sunlight filters through in muted gold. It is at once alien and oddly familiar, like a dream in which the sky looks almost right but never clears. Venus's clouds are more than an atmospheric curiosity. They are the very essence of the planet's mystery, the veil that hides its secrets, the mask that both reveals and conceals. And in their unbroken presence they remind us how much of planetary character is written not in rock or soil, but in the air above. For centuries the surface of Venus remained a mystery. No telescope could pierce its shroud of clouds. No observer on Earth could glimpse the features beneath. It was not until spacecraft arrived with radar instruments that the veil was finally lifted. By bouncing radio waves through the dense atmosphere, missions like NASA's Magellan in the 1990s created maps of Venus's surface in remarkable detail. What those maps revealed was a world of mountains, volcanoes, and vast plains of solidified lava, a planet that has been reshaped time and again by fire. The most striking discovery was the sheer abundance of volcanic features. More than 80% of the surface is covered in volcanic rock, making Venus the most volcanically dominated world in the solar system. While Earth is alive with tectonic activity, building mountains through the collisions of plates, Venus appears to have built its landscapes mostly through eruptions. Lava has flowed across the surface in sheets that stretch for hundreds of kilometers, smoothing out craters and creating broad, rolling plains. In some places, these plains are marked with wrinkle ridges, as though the planet's skin had puckered after cooling. Among these plains rise enormous volcanoes, some larger than anything found on Earth. One of the giants is Mount Mons, a massive shield volcano over 8 kilometers high and sprawling across hundreds of kilometers. To put that in perspective, it is nearly the same height as Mount Everest, but with a footprint large enough to cover an entire country. Mount Mons is not alone. Venus is home to countless volcanic peaks, domes, and complex structures, each a frozen monument to past eruptions. Some even appear suspiciously fresh, hinting that volcanic activity may not be entirely in the past. Unlike Earth, which has chains of volcanoes linked to tectonic plate boundaries, Venus seems to generate its volcanoes through hotspots scattered across the crust. Without the motion of plates, heat from the interior pushes upward in isolated regions, creating broad shield volcanoes and massive lava flows. Some areas show pancake domes, unusual formations where thick lava spread out in wide, flat mounds resembling stacks of pancakes. Others reveal coronae, vast circular structures caused by upwellings of magma that bulged the surface and then collapsed. These coronae can be hundreds of kilometers wide, leaving behind ring-like scars that mark the restless movement of heat below. The evidence of volcanic activity is everywhere. Impact craters, which accumulate steadily over time on most planets, are surprisingly scarce on Venus. This scarcity suggests that the surface is relatively young, likely less than 1 billion years old. Something, most likely a planet-wide episode of volcanic resurfacing, erased much of the older record. Scientists believe that immense eruptions may have flooded the surface with lava, burying craters, mountains, and entire landscapes beneath new rock. In effect, Venus seems to have hit a geological reset button, covering its history under a blanket of molten stone. Whether Venus is still volcanically active today is an open question. Some radar images from the Magellan mission hinted at changes in certain volcanic features over time, as though lava had flowed in recent geological history. More recently, data from orbiters and telescopes have suggested fluctuations in atmospheric gases, including sulfur dioxide, that could be linked to eruptions. If true, it means that beneath the crushing pressure and heat, Venus may still rumble with fiery life. The idea of a planet with volcanoes still smouldering, hidden beneath its acid clouds, adds an element of suspense to our picture of this strange twin. The mountains of Venus also add grandeur to its landscape. Maxwell Montes, the tallest mountain range, rises nearly 11 kilometers above the average surface level, higher even than Mount Everest when measured from base to summit. These mountains gleam brightly in radar images, likely because of metallic frost coating their peaks. At such extreme conditions, compounds like lead sulfide may condense at high altitudes, forming shiny deposits that reflect radar strongly. The effect is eerie, mountains capped not with snow but with metal frost shimmering beneath a sky of sulfur. Elsewhere, tesserae terrain offers some of the most complex and rugged landscapes in the solar system. Tesserae are regions where the surface has been twisted, buckled, and crisscrossed into intricate patterns of ridges and valleys. They represent some of the oldest surfaces on Venus, standing as ancient islands of fractured rock, among seas of younger lava. For geologists, tessera terrain is both fascinating and baffling, a record of tectonic-like processes on a planet without plate tectonics. Taken together, the surface of Venus is a study in volcanic artistry. Plains stretch outward like frozen seas of fire. Mountains rise under metallic frost. Volcanoes tower above the horizon, their flanks scarred by ancient lava flows. Coronae and domes scatter the land with patterns that speak of hidden forces pushing upward. It is a landscape shaped less by collision and erosion, as on Earth, and more by heat and pressure working from within. The absence of erosion is itself telling. On Earth, water and wind carve valleys, rivers, and canyons. On Venus, with no liquid water and only dense, slow-moving air near the ground, landscapes remain largely unweathered. Features endure for vast spans of time until they are buried by lava or deformed by interior stresses. This creates a surface that feels frozen in its violence, where every mountain and plain whispers of fire rather than water. For planetary scientists, Venus offers a glimpse of geological processes at their rawest. Without the moderating influence of oceans, weather, or moving plates, the planet shows us what happens when heat builds up and escapes directly through eruptions. The result is a patchwork of plains and peaks, young surfaces and ancient tesserae, all wrapped in a world where time seems measured not by seasons but by eruptions. And yet, despite its harshness, the surface features of Venus have a strange allure. There is grandeur in mountains capped with metallic frost, mystery in coronae that hint at hidden magmatic upwellings, and awe in volcanoes so vast they dwarf the giants of Earth. If we could ever stand on Venus and see them with our own eyes, the view would be unlike anything on this planet. A horizon of fire-forged landscapes under a yellow sky, silent except for the weight of the atmosphere pressing down. Venus hides these wonders beneath its clouds, keeping them secret until radar unveiled them to us. What we found was not the paradise once imagined by early dreamers, but a world scarred and reshaped by volcanic fury. Lava has been the sculptor, fire the architect, and the result is a surface that is at once alien and familiar, harsh and beautiful. It reminds us that planets are not static worlds, but dynamic beings, alive in their own ways, each telling a story of creation written in rock and flame. When radar first peeled back the veil of Venus, one of the most surprising revelations was that the planet has vast highland regions, places that rise far above the surrounding volcanic plains. These are not mountains in the sense of isolated peaks, but enormous swaths of elevated landmass that stretch across thousands of kilometers. Scientists quickly gave them names drawn from myth, with the two largest called Ishtar Terra and Aphrodite Terra. They are often described as Venus's continents, a term borrowed from Earth, though what lies beneath them is a puzzle very different from the continents we know. Ishtar Terra lies near the planet's north pole and covers an area roughly the size of Australia. Within it rises Maxwell Montes, the tallest mountain range on Venus, soaring nearly 11 kilometers above the mean planetary surface. To imagine such height, picture Mount Everest and then add a little more. The terrain here is rugged, marked by faults and fractures, and the bright radar reflections suggest materials that differ from the surrounding lowlands. Perhaps rocks altered by unique processes, or metallic frosts that condense at high altitude. Ishtar Terra feels like a citadel rising from a world of plains, a high fortress in a land where pressure and heat weigh down every horizon. Aphrodite Terra, by contrast, is far larger. Stretching across the equator for more than 10,000 kilometers, it is comparable in size to Africa. Its terrain is fractured and ridged, a jumbled tapestry of valleys and uplifted blocks. Radar mapping shows it as a place of extraordinary geological complexity, with features that hint at forces pushing and pulling the crust in ways we do not fully understand. Unlike Ishtar Terra's compact form, Aphrodite sprawls like a continent that has been stretched and stressed by internal upheaval. On Earth, continents are born of plate tectonics. The crust here is divided into moving plates that drift on the mantle below, colliding, rifting, and reshaping over geological time. Continents are buoyant, made of lighter rocks, and they persist while oceanic crust is continually recycled. Mountains rise where plates crash together, and rift valleys form where they pull apart. This dance of plates is central to Earth's geology, explaining not only mountains and oceans, but also earthquakes and volcanoes. Venus, however, tells a different story. Despite having highlands that resemble continents in appearance, it lacks the global system of shifting plates that defines Earth. Radar has revealed no evidence of continents drifting, colliding, or sliding beneath one another. Instead, Venus's crust seems to be one continuous shell, thick and immobile compared to Earth's fractured surface. This makes the existence of Ishtar Terra and Aphrodite Terra all the more intriguing. If plate tectonics did not lift them, then what did? One possibility is mantle plumes, giant upwellings of hot rock from deep inside the planet. On Earth, mantle plumes create features like the Hawaiian Islands, where rising magma pushes through the crust. On Venus, plumes may be powerful enough to swell entire regions upward, raising broad plateaus like Ishtar Terra and Aphrodite Terra. Another idea is that the crust of Venus, unable to move in plates, instead deforms locally, crumpling under stress and forming complex patterns of ridges and valleys. In this sense, Venus's continents may be the scars of a planet trying to release its internal heat without the luxury of plate tectonics. The absence of plate tectonics on Venus is one of its great geological mysteries. Earth's plates are driven partly by the presence of water, which lubricates faults and lowers the melting point of rocks. Without oceans, Venus may have lacked the conditions to break its crust into mobile slabs. Instead, its lithosphere thickened and locked into place, forcing the planet to vent its heat through eruptions and localized upheavals rather than through the slow, steady recycling we know on Earth. The result is a planet with features that echo our continents, but are born from different processes. Ishtar Terra and Aphrodite Terra are reminders that similar landscapes can arise through entirely different mechanics. Just as two siblings can grow into very different adults despite a shared origin, Earth and Venus have taken divergent paths in shaping their surfaces. One became a world of moving plates and drifting continents, the other a world of immobile crust and vast volcanic plains. These highlands also provide some of the most rugged and ancient terrain on Venus. Tessera regions found within them are intricate networks of intersecting ridges and valleys. They are thought to be among the oldest surfaces on the planet, predating the great volcanic resurfacing that buried much of Venus's history. Studying them is like peering into a window of deep time, glimpsing the struggles of a planet to reshape itself without the familiar tools of plate tectonics. From a human perspective, the idea of continents that never drift is both fascinating and unsettling. On Earth, our continents have wandered across the globe, merging into supercontinents and breaking apart again in cycles that span hundreds of millions of years. This motion has shaped climate, influenced evolution, and left its mark on every landscape. On Venus, the continents are locked in place, unmoving, their drama played out not through collisions, but through eruptions and crustal upheavals. It is a different kind of stage, one where the actors remain rooted while the set itself is consumed by fire. And yet, despite their alien origins, there is something strangely comforting in seeing echoes of our continents on another world. To know that there are highlands named for goddesses rising above seas of lava gives Venus a geography we can grasp. It makes the planet feel a little less distant, even as its processes remind us how alien it truly is. The continents of Venus also remind us that Earth's system of plate tectonics may not be universal. For decades, scientists assumed tectonics was an inevitable part of rocky planets. Venus challenges that assumption, showing us that even two nearly identical worlds can find different geological solutions. This has important implications for the study of exoplanets. where we often search for Earth-like worlds by size and distance from their stars, Venus warns us that similarity in broad strokes does not guarantee similarity in detail. A planet the size of Earth in the habitable zone may be a paradise, or it may be a Venus, its continents hidden beneath acid clouds, its crust locked in silence. So when we speak of Venus's continents, we must do so with a sense of both familiarity and wonder. They are not continents in the earthly sense, drifting across oceans and colliding to raise mountain chains. They are continents of another kind, lifted by plumes of fire, scarred by stresses we only half understand, and frozen in place by a crust that refuses to move. They are hidden not only by clouds, but by the assumptions we bring from our own planet. And in unveiling them, we are reminded once again that Venus is a twin only in size, not in spirit. A world that echoes Earth's geography and shape, while whispering an entirely different story beneath the clouds, high above the scorched surface of Venus, where the atmosphere begins to thin into hazy light. An invisible race is always underway. The air itself is moving so quickly that it circles the entire planet in just 4 Earth days. This phenomenon is known as superrotation, and it is one of the strangest features of Venus's atmosphere. While the solid body of the planet turns lazily backwards on its axis once every 243 Earth days, the atmosphere is in constant motion, whipping around at speeds that would dwarf the fiercest hurricanes on Earth. It is as if the skies of Venus decided not to wait for the sluggish ground and chose instead to run their own race. At the cloud tops, winds can reach more than 360 kilometers per hour. These speeds are strong enough to rival the most destructive storms we know, yet on Venus they are the normal state of affairs. Nothing interrupts them, nothing slows them down. The entire atmosphere is like a conveyor belt rushing around the planet endlessly, carrying sulfuric acid clouds in a perpetual stream. Imagine looking up and knowing that the sky above you is circling the globe faster than a jet plane, while the world beneath your feet barely moves at all. This bizarre contrast between atmosphere and surface raises fascinating questions. Why does the air move so fast when the planet itself barely rotates? Scientists have puzzled over this for decades, and while no single answer fully explains it, the likely causes lie in the complex dance of solar heating, planetary rotation, and atmospheric friction. The sun warms Venus unevenly, and with so much carbon dioxide and thick layers of cloud, the atmosphere stores that heat and redistributes it efficiently. Coupled with the planet's slow spin, this imbalance creates conditions that drive the winds into overdrive. Once set in motion, the superrotation maintains itself, like a giant engine that never quite loses power. For someone standing on the surface, the winds would be almost imperceptible. The air is so dense near the ground that even when it does move, it feels more like a sluggish current than a breeze. Objects would not sway as they do on Earth, because the sheer weight of the air resists motion. But high above, at altitudes where the air is thinner, the winds have free rein, rushing around the planet in colossal streams. From orbit, spacecraft have watched these clouds tearing across the sky, forming long, elegant streaks that show just how relentless the flow is. One of the more remarkable aspects of superrotation is how synchronized it is. On Earth, winds vary wildly across latitudes and seasons. Storms appear, dissipate, and shift directions. Venus, by contrast, is a study in uniformity. The clouds at the top of the atmosphere all race in the same direction, at nearly the same speed, like an entire world wrapped in a single jet stream. It is this steadiness that allows the atmosphere to lap the solid planet again and again, dragging the clouds around while the ground dawdles below. From a human perspective, the effect would be surreal. Imagine that you're on the surface of Venus and could somehow look upward through the haze. You would see the faint glow of the sun smeared into a dim disk, its light distorted by the atmosphere. Above you, though unseen, Winds faster than a jetliner are circling the world, tugging clouds in a global marathon. The contrast between the stillness of your immediate surroundings and the furious pace above would be almost eerie, a reminder that Venus is a world of contradictions. The scale of these winds is not just an atmospheric curiosity. They shape the entire planet's climate. By distributing heat so quickly, they help keep Venus's surface temperatures uniform, erasing differences between day and night, poles and equator. This is why Venus is as hot at the poles as it is at the equator, and as scorching at midnight as it is at noon. The winds are the great equalizers, spreading energy so effectively that the planet is locked in its furnace state everywhere, all the time. Superrotation also affects the chemistry of the atmosphere. Sulfur dioxide and other gases rise from volcanic outgassing, and the winds carry them around the globe, mixing them into the sulfuric acid clouds. In this way, the atmosphere becomes a giant chemical blender, keeping its ingredients stirred and balanced. Scientists studying the composition of the Venusian atmosphere must account for these currents, knowing that any sample is not just local but part of a global flow. Why the atmosphere moves in this way remains a lively area of research. Some models suggest that waves generated by solar heating transfer angular momentum upward, pushing the winds faster and faster until the whole atmosphere is carried along. Others point to turbulence and planetary scale waves that reinforce the flow. It is a mystery that continues to challenge planetary scientists, reminding us that even our nearest neighbours hold secrets we have yet to unravel. The beauty of these winds lies in their paradox. They are among the fastest in the solar system, yet they belong to a planet whose own spin is one of the slowest. They circle the globe in days, while the planet itself takes months to turn once. It is a mismatch that defies intuition, and yet it is perfectly natural for Venus. The skies do not wait for the ground. They have carved their own rhythm, indifferent to the sluggish rotation below. If you think of Venus as a character, then the atmosphere is its restless side, always in motion, never content to sit still. The solid body is the slow dreamer, turning backwards in languid defiance. Together they create a world of contrasts, stillness below, fury above, sluggishness in stone, speed in air. It is this duality that makes Venus so intriguing, a reminder that planets are not uniform machines but living systems of contradiction and complexity. So when we gaze at Venus from Earth and admire its brilliance in the night sky, we are seeing more than just reflected sunlight. We are seeing the signature of an atmosphere in motion, clouds carried around the planet at breathtaking speed. Beneath those clouds lies a silent, sweltering surface that moves almost imperceptibly, but above them the winds are in constant flight. Venus is a world where the air outpaces the ground, where the sky itself is a restless traveller, circling endlessly while the planet lingers behind. Lightning has always held a certain drama for us on Earth. A flash across a darkened sky, a crack of thunder rolling through the air. It is both beautiful and frightening, a reminder of the power hidden in clouds. For Venus, wrapped in a permanent veil of sulfuric acid mist, the question has long been whether such electric storms exist there as well. Scientists have debated this for decades, and while the evidence has often been tantalizing, it has also been elusive. Yet again and again, hints suggest that even in the suffocating skies of Venus, lightning may flash. The earliest clues came from the Soviet Venera missions. When their landers parachuted down through the atmosphere, instruments picked up bursts of electromagnetic noise, the kind that lightning produces. These signals were not clear photographs or direct flashes, but radio disturbances, sudden bursts that looked remarkably like the signature of storms. Later, spacecraft like NASA's Pioneer Venus Orbiter and the European Space Agency's Venus Express reported similar data. They detected low-frequency radio waves, called Whistler waves, which on Earth are linked to lightning strokes. The signals seem to come from within the clouds themselves, hinting at violent electrical activity hidden inside the perpetual haze. But confirming lightning on Venus is not as straightforward as it sounds. Unlike Earth, where storms are visible and thunder is audible, Venus hides its sky beneath layers of cloud. No spacecraft has ever seen a clear bolt of lightning on its surface. Instead, the evidence is indirect. Electromagnetic disturbances, bursts of radio static, or brief flashes detected by orbiters peering through the haze. Each clue is intriguing, but none is beyond doubt. Some scientists argue that the signals could be caused by other processes, such as interactions between the solar wind and the planet's thick atmosphere, or by turbulence unrelated to electrical discharges. The challenge is made greater by the nature of Venus's clouds. They are not made of water droplets, as ours are, but of sulfuric acid mixed into dense layers of carbon dioxide. On Earth, lightning is generated when ice crystals and water droplets collide within towering storm clouds, separating charges until the difference becomes too great, and a discharge occurs. On Venus, the process would have to work differently. Sulfuric acid droplets may rub and collide in ways that allow charge separation, or perhaps volcanic eruptions inject particles into the atmosphere that help spark lightning. The physics is still uncertain, but the possibility is very real. If lightning does occur, its behavior would be unique. The dense atmosphere would slow the strokes, making them last longer than the sharp flashes we know on Earth. Some models suggest that Venusian lightning could glow for fractions of a second longer, turning each bolt into a slower, more lingering event. Instead of jagged forks of brilliant white, the flashes might be muted by the clouds, glowing as diffuse sheets of light that illuminate the haze rather than tearing it open. From the surface, if one could see through the thick air, lightning would appear as eerie bursts diffused into the yellow sky, a faint but haunting illumination. Comparisons with Earth are both fascinating and humbling. Our storms are fueled by water vapor rising and condensing into towering cumulonimbus clouds. On Venus, there is no water to drive such weather, no ocean to feed evaporation. Instead, the thick atmosphere and sulfur chemistry must provide the energy. Where Earth's storms may rage across continents, Venus's lightning, if it exists, is confined within endless layers of acid mist, hidden from view but no less powerful. The effect would be less about grand bolts streaking across the sky and more about silent, ghostly pulses buried in the clouds. The idea of storms on Venus challenges the imagination. To stand there, even in thought, is to imagine a sky without breaks, without blue, filled instead with swirls of pale yellow and grey. Into that sky, occasional flashes of lightning might glow, muffled by the haze, as if the heavens themselves were lit from within. No thunder would reach your ears, at least not in any form we would recognize. The dense air would carry sound differently, perhaps muting the crack of a strike into a low rumble that never quite escapes the weight of the atmosphere. It would be less a sharp crash and more a heavy vibration, felt as much as heard. Lightning, if it does occur, also plays a role in the chemistry of the planet. On Earth, lightning helps create nitrogen compounds that fertilize ecosystems. On Venus, discharges could alter sulfur and carbon chemistry, creating short-lived compounds that shape the balance of the atmosphere. This makes the search for lightning not just about confirming storms, but about understanding how Venus maintains its current climate. Each flash could be part of the hidden engine that drives the planet's atmospheric cycles. Despite the uncertainty, many planetary scientists lean toward the conclusion that Venus does indeed produce lightning. The weight of evidence from multiple missions, combined with plausible physical mechanisms, makes it difficult to dismiss. Future missions will carry instruments specifically designed to detect it more clearly, perhaps even capturing direct images of flashes within the clouds. Confirming lightning would add one more layer of complexity to an already complex planet. A world not only of crushing pressure and endless heat, but also of storms flashing unseen in the sky. There is something poetic in the thought that Venus, long associated with beauty and love in human culture, hides within its clouds storms as violent as any on Earth. the goddess-like planet, glowing as a jewel in our sky, may in reality be alive with electrical fury, each flash a reminder that beneath beauty lies power. It is a duality that suits Venus well, alluring from afar, intimidating up close, a world where even storms are transformed into something alien. So while we may never stand beneath Venus's clouds and watch lightning fork across the sky, we can still picture it. Imagine that endless golden haze suddenly illuminated from within, not by the sun, but by a hidden surge of electricity. Imagine the silence of a surface where sound cannot travel easily, interrupted by faint vibrations of thunder that never quite reach the ear. It would be a storm both familiar and strange, a reminder that lightning is not unique to Earth, but a natural language of planets, written in sparks across the sky. On Venus, lightning remains partly mystery, partly certainty. The clues are there, scattered in bursts of radio waves and whispers from orbiters, waiting for confirmation. And even if we cannot see the bolts directly, the thought of them adds to the haunting picture of a planet both beautiful and brutal. Venus is not only a furnace and a veil of clouds, it may also be a world of hidden storms, where electricity flickers in the mist, writing its own story in flashes we are only just beginning to understand. In the story of exploring Venus, the Soviet Union holds a remarkable place. At a time when even reaching orbit was considered a triumph, Soviet engineers set their sights on a planet that is perhaps the harshest in the solar system. The Venera program, which unfolded between the 1960s and 1980s, was a series of missions that dared to touch down on a world where heat, pressure, and acid clouds conspire against anything human-built. These pioneers were the first to pierce the veil of Venus, delivering images and data that transform the way we see our nearest planetary neighbour. The early attempts were anything but easy. The first Venera missions were launched in the early 1960s, soon after Yuri Gagarin became the first human to orbit Earth. These spacecraft were small, with limited instruments, and they struggled simply to reach Venus at all. Some missed their target entirely, others failed in flight, and still others were crushed by the planet's atmosphere before they could send back meaningful data. But each attempt taught valuable lessons. Even failures were steps forward, guiding the design of sturdier craft and more ambitious missions. By 1967, progress began to show. Venera 4 successfully entered Venus's atmosphere, becoming the first probe ever to transmit data from within the air of another planet. It did not survive all the way to the surface, but what it revealed shocked scientists. The atmosphere was far denser and hotter than many had predicted. Instead of being a mild, tropical world hidden beneath the clouds, Venus turned out to be a crushing furnace of carbon dioxide, with pressures far greater than any human could withstand. This revelation ended centuries of speculation that Venus might harbour lush jungles or oceans. The dream of an Earth-like twin evaporated in a rush of carbon dioxide readings and temperature data. The Soviets did not stop there. They refined their designs, building spacecraft with thick pressure vessels, strong enough to endure conditions more like the deep sea than the open sky. Venera 7, launched in 1970, made history as the first spacecraft to successfully land on another planet and transmit data back to Earth. Its descent was perilous, slowed by parachutes that strained under the dense air. When it finally touched the surface, the probe was battered and weakened, managing to send a faint signal for about 23 minutes before succumbing to the furnace around it. That whisper of data, captured across the vast distance of space, was a triumph. The first direct communication from the surface of another world. In the years that followed, the Soviets pressed further. Venera 9 and Venera 10 in 1975 delivered the first photographs from the surface of Venus. These black and white images showed a rocky landscape under a heavy hazy sky, the horizon bent by the thick atmosphere. For the first time in history, humanity saw the surface of a planet beyond Earth, not in imagination, but in reality. The images were grainy and ghostly, but their impact was profound. They revealed slabs of rock scattered across the landscape, confirming that Venus was solid ground, not an ocean world or a swamp. The challenges of operating on Venus were staggering. The pressure at the surface is the same as being almost a kilometre underwater on Earth. The heat would melt lead and destroy most electronics within minutes. To endure even briefly, the Venera landers had to be built like miniature submarines, with walls of titanium and cooling systems packed into their small frames. Even so, none of them lasted long. Most survived between 40 minutes and 2 hours before their instruments failed, overwhelmed by the unrelenting environment. Yet in those short lifetimes, they transmitted data that rewrote textbooks. Venera 13, which landed in 1982, was perhaps the most successful. It lasted for over 2 hours, sending back colour photographs of its surroundings and analysing the soil with an onboard laboratory. Its pictures showed a landscape littered with flat, layered rocks under a golden sky, lit dimly by sunlight filtering through the clouds. For the first time, humans saw Venus in colour, not as an artist's guess, but as reality. The land was orange-brown, the sky a murky yellow, the ground cracked and dry. In those images, the world of Venus became vivid, both alien and strangely familiar. The data gathered by the Venera missions revealed that Venus's surface is dominated by volcanic rock, that its skies are full of sulfuric acid, and that its climate is stable only in its hostility. Temperatures do not vary between day and night, pole and equator. The planet is uniform in its heat, unyielding in its conditions. The probes even recorded the sounds of the wind, a low whisper carried across the dense air, adding an eerie soundtrack to the alien landscape. What made these achievements all the more impressive was the technology of the time. In an era when computers were far less powerful than a modern phone, engineers managed to build machines that could cross space, enter an atmosphere of unimaginable density, and survive long enough to send back photographs from another planet. They did so without the luxury of modern materials or digital imaging. Every success was the result of ingenuity, persistence, and a willingness to push against the limits of what seemed possible. The Venera program gave humanity its first close look at Venus, and in doing so it shattered illusions. For centuries, Venus had been imagined as a paradise, a second Earth. Science fiction writers filled it with steaming jungles, exotic creatures, and vast oceans hidden under clouds. The reality was different. A hellish world of rock and fire, clouds of acid, and pressure that crushes. And yet, in revealing the truth, the Venera missions made Venus more fascinating, not less. The planet's beauty lies not in what we once hoped it might be, but in what it actually is. An extreme, alien environment that challenges our understanding of planetary science. These Soviet pioneers stand as a testament to human curiosity and determination. They showed that exploration does not always require long-lasting presence to make a difference. Sometimes, a few minutes of survival in a hostile world is enough to open a window into the unknown. Those brief transmissions, those flickering images, and those streams of data were milestones in our journey outward from Earth. When we look at Venus in the night sky today, shining like a bright jewel, it is worth remembering that we have touched its surface, if only briefly. Our machines have stood there, endured the pressure and the heat, and sent back their last words before being silenced. It is a reminder that even the most impossible seeming goals can be reached, and that exploration often begins not with comfort or permanence, but with small, courageous steps. The Venera missions remain among the great achievements of space exploration, not because they tamed Venus, but because they dared to meet it on its own terms, however briefly. For most of human history, Venus was a mystery wrapped in light. We could see its brilliance from Earth, track its movements across the sky, and imagine what lay beneath its veil of clouds, but no telescope ever revealed its surface. Even when probes from the Soviet Union landed there, Their cameras showed only small patches of rock, captured during brief, gasping minutes before the heat silenced them. The true face of Venus remained hidden until radar unlocked the view. In the 1990s, NASA's Magellan spacecraft transformed our understanding of the planet, peeling back the clouds with radio waves to reveal a world of volcanoes, plains, fractures, and wonders that no human eye had ever seen before. Launched in 1989 and arriving at Venus in 1990, Magellan was not a massive flagship mission, but a relatively modest spacecraft, assembled from spare parts left over from earlier programs. It was a testament to ingenuity, proving that sometimes the greatest discoveries come not from lavish resources, but from clever design and precise focus. Magellan carried a single, powerful instrument, a synthetic aperture radar system capable of mapping the surface of Venus in astonishing detail. While visible light could not penetrate the thick sulfuric acid clouds, radar could slip through, bounce off the ground, and return with data that scientists could assemble into images. Over the course of 4 years, Magellan orbited Venus nearly 5,000 times, slowly building a global map. By the time its mission ended in 1994, it had imaged about 98% of the planet's surface, a level of coverage unmatched for decades. For the first time, the hidden world beneath the clouds was revealed not as a flat, featureless plain, but as a dynamic, geologically rich landscape. The images were not photographs in the traditional sense. Radar produces textures and contrasts rather than colours, but they were nonetheless breathtaking. They showed mountains, valleys, volcanoes, and vast plains of lava, every detail speaking of a planet shaped by fire. One of the most striking discoveries was the sheer abundance of volcanic structures. Magellan revealed more than 160 large volcanoes and countless smaller ones, scattered across the surface like embers from a cosmic fire. Some were shield volcanoes, broad and gently sloping, while others were steep-sided and complex. The variety was unlike anything on Earth. Among the most distinctive were pancake domes, wide, flat mounds formed by thick, sticky lava spreading outward in layers. These structures, dozens of kilometers across, looked as though some giant hand had stacked batter on the planet's surface. Equally fascinating were the coronae, enormous circular features created by upwellings of magma from deep within the mantle. These could stretch hundreds of kilometers across, with ridges, fractures, and collapsed centers that made them look like gigantic scars on the land. Coronae seemed to tell the story of Venus's restless interior, where heat has no easy escape through moving tectonic plates, and so bursts upward in dramatic pulses. The discovery of these unique formations suggested that Venus's geology operates under rules very different from Earth's. Magellan also mapped vast volcanic plains, regions where lava had once poured out and spread for hundreds of kilometers, burying older terrain beneath smooth, fresh rock. These plains confirmed that volcanic resurfacing was a dominant process on Venus. The lack of old impact craters supported the idea that, at some point in the last billion years, much of the planet had been repaved by eruptions. Whether this happened gradually or in cataclysmic bursts remains debated, but the evidence was clear. Venus had not been geologically quiet. Fractures and faults crisscrossed the surface as well, painting it with patterns of stress and strain. Some regions showed long rift valleys where the crust had stretched apart, while others displayed tessera terrain, dense networks of ridges and grooves that hinted at ancient, violent reshaping. These tesserae appeared brighter in radar images, reflecting signals differently from the smoother plains. They may be among the oldest features on Venus, survivors from a time before the great volcanic floods erased much of the past. Mountains rose out of the haze too, most notably Maxwell Montes, which soared nearly 11 kilometers above the surrounding landscape. Bright in radar reflections, these peaks stood as reminders that Venus, though lacking Earth's plate tectonics, could still build immense elevations through other means. Some scientists suggested that mantle plumes forced these regions upward, piling rock until the crust gave way under the strain. Others proposed long, slow deformations of the lithosphere. Whatever the cause, the mountains of Venus were now visible for the first time, their summits glittering in radar echoes. The images from Magellan were not just geological maps, they were works of alien art. Lava plains looked like oceans frozen in motion. Coronae resembled giant flowers or mandalas etched into stone, and fractures stretched like scars across the face of the world. Even without colour, the radar images carried a stark beauty, showing a planet that was at once alien and strangely familiar. For geologists, each image was a treasure trove of information. For the rest of us, they were a revelation that Venus is not a dull, featureless orb, but a planet with landscapes as dramatic as any on Earth. The mission also demonstrated the power of radar in planetary exploration. Where cameras fail, radio waves succeed, turning opaque atmospheres into transparent windows. This technique not only gave us Venus, but also laid the groundwork for future missions to icy moons and cloud-covered worlds. Magellan proved that patience and persistence could unlock secrets hidden for billions of years. By the time the mission ended, Magellan had done more than map Venus. It had changed how we think about the planet. We no longer imagined it as a smooth, uniform globe beneath its veil, but as a dynamic, volcanic world with unique processes and structures. The dream of jungles and oceans was long gone, replaced by a vision that was harsher but also far more scientifically intriguing. Venus was revealed not as Earth's gentler twin, but as its fiery sibling, reshaped by heat and pressure into something alien. In 1994, Magellan was deliberately plunged into Venus's atmosphere, burning up as it fell. Its work was complete, its maps secure, its legacy ensured. From that point on, every scientific discussion of Venus relied on the radar eyes that had seen beneath the clouds. Even today, decades later, Magellan's maps remain the most detailed views we have of the planet. They are the foundation for every future mission, every question we ask about volcanoes, resurfacing, and tectonics on our neighbouring world. When you look at Venus shining in the sky, remember that its beauty hides a surface now known in extraordinary detail thanks to a spacecraft built of spare parts and persistence. Magellan turned mystery into knowledge, clouds into clarity, and speculation into evidence. It showed us a hidden world, a planet alive with scars, plains, and peaks, each telling a story of fire and change. In its radar echoes, Venus finally revealed itself, and what it showed was a world as complex and compelling as any in the solar system. When most people imagine human colonies on other worlds, their thoughts turn to Mars. Red deserts, domed habitats, and dusty horizons dominate the vision of life beyond Earth. But for a certain group of dreamers, the future might instead float above the surface of Venus. It sounds counterintuitive at first. Venus, the furnace world, the planet where spacecraft survive only for minutes before being crushed and melted. Yet, in its upper atmosphere, conditions are surprisingly gentle, almost Earth-like. That curious fact has inspired some of the boldest ideas in space exploration. Floating cities adrift in the golden clouds. The concept begins with the recognition that not all of Venus is equally hostile. On the surface, pressure is 90 times that of Earth, and the temperature is hot enough to melt lead. But climb to an altitude of about 50 to 60 kilometers, and the picture changes dramatically. There, the pressure drops to roughly 1 bar, the same as sea level on Earth. Temperatures settle into the comfortable range of 20 to 30 degrees Celsius. In fact, if you could somehow shield yourself from the acid mist, you might find the conditions not so different from standing outdoors on a warm day back home. It is one of the strangest twists in planetary science. Within the thickest and most unwelcoming atmosphere in the solar system lies a hidden region of relative comfort. This is where the dream of floating cities comes alive. Instead of colonizing the searing ground, engineers have proposed suspending habitats in the clouds. balloons filled with lighter-than-air gases such as helium or even breathable air could lift structures into the safe zone above the surface. Because Venus's atmosphere is mostly carbon dioxide, plain old oxygen and nitrogen, the air we breathe, would act as a buoyant gas, much like helium on Earth. A habitat filled with air would naturally float, a kind of self-sustaining balloon carrying its occupants across a golden sky. Designs for such habitats often resemble enormous airships or clusters of connected balloons supporting platforms, domes, or towers. NASA's High-Altitude Venus Operational Concept, or HAVOC, envisioned spacecraft carried aloft on giant balloons, with crews living and working in the temperate atmosphere for weeks at a time. These missions would avoid the crushing dangers of the surface entirely, while still allowing scientists to study the planet's weather, chemistry, and geology from above. From the safety of their drifting outposts, explorers could gaze down through breaks in the clouds at the volcanic plains below and up at the dim sun shining through the haze. Science fiction writers have long embraced this idea. In novels, films, and artwork, Venusian skies are sometimes filled with shimmering platforms, tethered towers, or entire cities riding the winds. The image is undeniably captivating. Instead of trudging across barren rock, humanity would live among the clouds, suspended in an endless sunset. Skylines would consist not of skyscrapers rooted in the ground, but of buoyant domes swaying gently in the upper winds, with airships navigating the skies like cosmic ferries. It is a vision that merges the romance of old-world ballooning with the frontier spirit of space exploration. The appeal of Venus's upper atmosphere lies not only in its comfort but also in its accessibility. Venus is closer to Earth than Mars, meaning shorter travel times and more frequent launch windows. The dense atmosphere would also provide protection against cosmic radiation, which is a serious challenge for Mars habitats exposed on a barren surface. Floating in Venus's clouds, colonists would be shielded by kilometers of carbon dioxide and sulfuric acid mist, safe from the constant bombardment of high-energy particles that sweep through interplanetary space. Of course, the obstacles are immense. Sulfuric acid droplets permeate the clouds, threatening to corrode metals, plastics, and fabrics. Any floating city would need coatings, shielding, or innovative materials to survive constant chemical assault. Energy would also be a challenge. Solar panels could function, but the sun's light is filtered and dimmed by the clouds, leaving colonists to seek efficient ways of harvesting power. Then there is the issue of mobility. Winds at these altitudes circle the planet in just 4 Earth days, meaning that a floating habitat would drift around the globe rapidly, whether it wanted to or not. Steering mechanisms might allow some control, but residents would likely accept that their home would forever be carried by the global flow, a city perpetually in motion. Yet the problems are not insurmountable in theory. Corrosion-resistant materials already exist on Earth, designed for chemical plants and harsh industrial environments. Power could be supplied by a mix of solar energy and systems carried from Earth, and drifting cities might not see their mobility as a flaw, but as a feature. Imagine living in a community that circles the entire planet every few days, experiencing dawn, dusk, and midnight in an endless cycle as the golden clouds stream by. Instead of being anchored to a single place, such a city would be a true traveller of Venus, its journey never ending. For scientists, the advantages of such outposts would be profound. From within the clouds, instruments could measure the chemistry of the atmosphere, track weather systems, and study lightning and winds up close. Radar systems could map the surface below in detail, adding to the legacy of the Magellan mission. Samples of cloud particles could be collected and analysed directly, answering questions about their composition and behaviour. And perhaps most intriguingly, such missions could search for signs of life. Some researchers have speculated that microbial organisms might survive in the relatively temperate regions of Venus's atmosphere, clinging to droplets and feeding on chemical energy. A floating laboratory drifting through the clouds would be the perfect way to test this idea. Beyond the science, the cultural impact of cloud cities would be enormous. Humanity has always dreamed of lifting itself into the air. Hot air balloons, zeppelins, and aircraft all testify to our fascination with floating above the ground. To extend that dream to another planet, to build cities that drift among sulfuric clouds under an alien sun, would be a leap of imagination come true. Children growing up in such a place would know not landscapes of grass and soil, but endless horizons of glowing mist. Their view would be volcanic plains far below, unreachable, and skies above that never cleared to blue. Their home would be the air itself. For now, these ideas remain speculative, constrained by technology, funding, and the priorities of space agencies. Mars still dominates discussions of colonization, with its more familiar terrain and solid ground. But Venus holds a strange allure, precisely because it is so different. The idea of thriving not by fighting the planet's most dangerous aspects, but by rising above them has a poetic symmetry. We do not conquer Venus by braving its furnace floor. We coexist with it by floating in its gentler skies. In the end, the dream of floating cities on Venus is not just an engineering proposal, it is an expression of human imagination, a reminder that exploration often begins with daring ideas that seem impossible at first. Whether or not we ever build platforms among the golden clouds, the vision inspires us to see planets not just as barren rocks, but as worlds with potential. Venus may never host jungles or oceans as once imagined, but perhaps it could one day host cities adrift in the mist, places where humanity finds a way to live among fire and acid by choosing instead to rise above them. From the moment humans first tilted their heads back and noticed the brightest light in the twilight sky, Venus has held a special place in imagination. Its glow is so steady and brilliant that even the most casual sky gazer cannot miss it. Long before telescopes, mathematics, or space probes revealed the truth of what Venus is, it was already a goddess, a sign, a guide, and a mystery woven into myth. To civilizations scattered across the world, the morning and evening star was never just another light. It was a symbol of beauty, desire, power, and change. The planet takes its modern name from the Roman goddess Venus, the embodiment of love, beauty, and fertility. To the Greeks, she was Aphrodite, born from the sea foam and adored for her allure. The connection feels natural enough. A celestial body that outshines all stars except the sun and moon seemed destined to be linked with attraction and charm. Poets and artists found inspiration in that gleaming light, equating its constancy with devotion and its brightness with desire. Even in a night sky full of dazzling points, Venus stood apart, radiant like a jewel, serenely beautiful. But Venus's role in mythology stretches far beyond the classical world. In Mesopotamia, one of the earliest centers of astronomy, Venus was associated with the goddess Inanna, later known as Ishtar. Inanna was a figure of both love and war, embodying the duality of tenderness and ferocity. The two faces of Venus, as the morning star and the evening star, fit perfectly with Inanna's shifting roles. She was both a bringer of fertility and a destroyer in battle, much like Venus appeared both at dawn and dusk, heralding beginnings and endings. Babylonian records of Venus are among the oldest astronomical writings we have, with tablets carefully charting its appearances and disappearances. The planet was not simply observed, it was revered, feared, and consulted as an omen of human affairs. The Maya, too, placed enormous importance on Venus. They tracked its cycles with astonishing precision, recording its movements in the Dresden Codex. To them, Venus was not just a bright light, but a celestial influence, guiding the timing of rituals, agriculture, and even warfare. Its reappearance as the morning star was thought to herald significant events, sometimes linked to conflict or the rise of rulers. To stand under the dawn sky and see Venus gleaming would have carried weight and consequence in Maya culture, a reminder that the heavens were woven directly into the fabric of daily life. In Polynesian traditions, navigators crossing vast stretches of ocean used Venus as one of their guides. Rising in the east or setting in the west, it became a point of reference in the night sky, helping sailors steer between islands scattered across thousands of kilometers of ocean. Where modern explorers might carry compasses and maps, ancient seafarers carried knowledge of the stars, and Venus was one of the most reliable companions. Its brightness meant it could be trusted, a steady beacon in the shifting sky. In ancient China, Venus was called the Great White Star and was linked to the element metal in traditional cosmology. It was one of the 5 planets, each associated with natural forces and cycles of change. Venus's brilliance and regularity made it a marker of celestial order, tied to the rhythms of heaven that govern the affairs of emperors and dynasties. In Japan, too, it appears in poetry and folklore as a symbol of renewal and beauty, an inspiration for art and verse. What is remarkable is how universal Venus's cultural presence has been. From the Middle East to the Americas, from Asia to the Pacific, nearly every civilization that charted the skies paid special attention to this wandering star. It was bright enough to command notice and regular enough to invite prediction, yet mysterious enough to spark myth. Venus became a kind of cultural mirror, reflecting the values and concerns of the people who watched it. For some, it was love and fertility. For others, war and power. For still others, guidance and navigation. And yet, in all of these myths and associations, there is a great irony. While Venus was celebrated as a symbol of beauty, love, and order, its true nature is anything but gentle. When spacecraft finally revealed the conditions beneath its clouds, the image of a goddess was replaced with that of a furnace. Instead of gardens of desire, there are volcanic plains. Instead of a paradise of fertility, a desert of fire. The goddess of love, as it turns out, is a world of crushing pressure, sulfuric acid, and unrelenting heat. This irony is not a disappointment, but rather an enrichment. The contrast between Venus's symbolic beauty and its scientific reality deepens its intrigue. A planet that glows so brightly from Earth could easily have been lifeless and dull. Instead, it is alive with extremes, a reminder that beauty and danger often walk hand in hand. In a way, Venus's true nature makes its cultural associations even more poignant. Humanity saw beauty in the sky, not knowing that beneath the glow lay a world utterly inhospitable. The goddess of love hid a heart of fire. Even today, Venus continues to inspire in art and culture. Its name graces paintings, music, poetry, and even spacecraft. Gustav Holst gave it a serene, reflective theme in his orchestral suite The Planets. Modern writers still invoke Venus as a symbol of longing and brilliance, sometimes romantic, sometimes tragic. In popular culture, Venus remains a muse, standing as one of the few planets that can be identified by anyone with just a glance at the night sky. The planet's duality, symbol of love above, furnace below, speaks to the way humans create meaning. We project beauty onto a distant light because it shines for us, even if the truth behind it is indifferent. Venus does not need to be gentle to be inspiring. Its hostility does not erase its cultural role. If anything, it amplifies it, reminding us that myth and reality often diverge, yet both have their place in shaping how we understand the cosmos. So when you see Venus glittering at twilight, you are not just looking at a planet. You are gazing at a story thousands of years old, a story told by Mesopotamian priests, Greek poets, Maya astronomers, and Polynesian navigators. You are seeing the same light that guided ships, foretold wars, and inspired paintings. And you are also, perhaps without realizing it, looking at a world whose beauty is only skin deep, whose reality is harsher than any myth ever imagined. That combination, bright goddess above, volcanic inferno below, makes Venus one of the most fascinating paradoxes in both culture and science. It is, in the truer sense, a planet of love and fire. On Earth, the greenhouse effect is a quiet friend. Without it, our planet would be frozen, a barren sphere of ice with little hope of sustaining life. Gases such as carbon dioxide, methane and water vapour trap just enough of the sun's warmth to make Earth a home for oceans, forests and people. But on Venus, that same principle has been taken to an extreme. There, the greenhouse effect is not a friend but a tyrant, locking the planet in an oven that never cools. Comparing the two worlds, so alike in size and composition, yet so different in fate, gives us one of the clearest lessons about the fine balance of climate. The difference begins with scale. On Earth, carbon dioxide makes up a tiny fraction of the atmosphere, measured in parts per million. Those few molecules are enough to hold in heat, but they are balanced by oceans, forests and rocks that absorb and recycle them. On Venus, carbon dioxide is not a trace gas, but the very substance of the air. More than 96% of the atmosphere is carbon dioxide, piled on in such volume that pressure at the surface is like being a kilometre underwater on Earth. This density, combined with the planet's closeness to the Sun, turned a mild greenhouse into a runaway one. Once begun, the cycle fed on itself. Warming caused oceans to evaporate, water vapour trapped more heat, and with no way to draw carbon out of the atmosphere, the process accelerated until the planet was locked in permanent fire. On Earth, the oceans play a crucial role in preventing such a fate. Water not only moderates temperature, but also acts as a sink for carbon dioxide. Over millions of years, carbon is drawn from the air, dissolved in seawater, and locked into rocks as carbonate minerals. Plate tectonics completes the cycle, recycling carbon through volcanoes and subduction zones. Life itself has become part of this balancing act. Plants and microbes absorb carbon dioxide, releasing oxygen and maintaining a breathable atmosphere. This interplay has kept Earth's climate relatively stable for billions of years, despite the sun slowly brightening over time. Venus, by contrast, lost its oceans. Without water to absorb and regulate carbon dioxide, the gas built up unchecked. Without plate tectonics, the carbon could not be recycled effectively into the interior. Without life, there was no biological drawdown of greenhouse gases. The result is a world where the greenhouse effect is absolute, a system that tipped past the point of recovery and has remained there ever since. Venus became a cautionary tale written across the solar system, a reminder that climate can be both delicate and unforgiving. For scientists studying climate change on Earth, Venus is more than a curiosity. It is a laboratory. The physics of greenhouse gases does not change from planet to planet. Carbon dioxide absorbs infrared radiation in the same way whether it floats above Paris or above Mat Mons. By studying how Venus's atmosphere responds to sunlight, heat and circulation, we refine our understanding of how greenhouse gases behave under extreme conditions. Models of Earth's climate, which predict future warming trends, are strengthened by data from our sister planet, even if the scales are vastly different. There are also warnings written in Venus's history. While Earth will never become another Venus overnight, the comparison shows how fragile balance can be. A small increase in greenhouse gases on Earth is enough to shift weather patterns, melt glaciers, and raise sea levels. On Venus, once that balance tipped, the change was irreversible. Oceans boiled away, carbon dioxide dominated, and the planet was sealed into its fate. It reminds us that climate is not a static backdrop, but a living system, one capable of changing dramatically when pushed too far. The lessons resonate in today's world. Industrial activity has increased carbon dioxide in Earth's atmosphere to levels not seen in millions of years. The warming that results is not a runaway greenhouse, but it is enough to stress ecosystems, alter rainfall patterns and amplify storms. By looking to Venus, we see the logical extreme of these processes, a neighbour planet that shows what happens when the greenhouse effect becomes unchained. While Earth is nowhere near such conditions, the principle is clear. Tipping points matter, and balance is not guaranteed. Some researchers even suggest that Venus was once more Earth-like, with oceans and mild conditions. If that is true, then Venus did not begin as a hostile world, but became one through changes in climate. That possibility makes the comparison even more striking. Two planets born side by side, alike in so many ways, diverged into paradise and inferno. The only differences were distance from the sun, the presence of water, and the feedback loops that followed. It is a reminder that small distinctions in initial conditions can lead to vastly different outcomes. The irony is that Venus, long symbolized as the goddess of love and beauty, is one of the most unloving places imaginable. Its glow hides a warning. In the brilliance that inspired myths, we also find a reflection of our own vulnerability. The same physics that makes Earth livable is what makes Venus unbearable. We do not need to fear becoming a second Venus, but we can take its story as a caution about complacency. Climate is not permanent. It responds to chemistry, feedback, and time. Studying Venus also expands our search for life beyond Earth. Many exoplanets discovered around other stars are super-Venuses, worlds similar in size but orbiting close to their stars, shrouded in thick atmospheres. Understanding Venus helps us recognize the difference between potentially habitable worlds and those already lost to runaway greenhouses. Every time we refine our models of Venus, we refine our ability to judge distant planets, distinguishing between homes for life and places of fire. Perhaps the most humbling lesson is perspective. Earth's climate system works because of cooperation between oceans and atmosphere, geology and biology, sunlight and chemistry. Venus shows us what happens when that cooperation fails, when water vanishes and carbon piles up unchecked. It is not just a world that diverged from ours. It is a mirror tilted to one side, showing the consequences of imbalance. In its endless yellow haze and its unbroken heat, Venus embodies the idea that nature does not forgive extremes. So, The Tale of Two Greenhouses is not simply a story about two planets. It is a story about the razor's edge between habitability and hostility, about the balance of gases and oceans, and about how fragile that balance can be. Earth's greenhouse effect is the reason we live, breathe, and thrive. Venus's greenhouse effect is the reason it became a furnace. Between them lies the reminder that we must cherish the balance we have, for it is neither guaranteed nor eternal. Venus teaches us that the line between paradise and inferno can be thinner than we imagine. The Venus we know today is a place where survival is impossible, a world of searing heat and crushing pressure. Yet hidden in its past may be a very different story. For decades, scientists have wondered if Venus could once have been more like Earth, a planet with oceans, clouds of water instead of acid, and perhaps even conditions that were hospitable to life. The idea may sound fanciful given the inferno we see now, but models of planetary evolution suggest that such a scenario is not only possible but perhaps even likely. Venus might once have been a paradise, only to turn itself into a furnace. Clues to this gentler past begin with the fact that Venus and Earth are so similar in size, density, and composition. Both were formed from the same swirling disk of dust and gas around the Sun. Both inherited water from icy planetesimals that rained inward during the chaos of planetary formation. If Earth received enough water to fill its oceans, it is reasonable to assume Venus did too. Early in its history, the Sun was dimmer, and Venus, though closer in, might have been cool enough for liquid water to pool on its surface. Oceans could have formed, evaporating into clouds and raining back down in cycles not unlike those on Earth. Computer models have strengthened this picture. When scientists simulate the climate of a young Venus, assuming oceans a few hundred meters deep, and a sun that was about 30% dimmer than today, the results often show stable, temperate conditions. Clouds would have formed in the tropics, shielding the surface from direct sunlight and creating a balance that allowed liquid water to persist. In some scenarios, Venus might have remained Earth-like for hundreds of millions of years, perhaps even up to 2 billion years. That is more than enough time for life, at least in microbial form, to arise if the conditions were right. But something tipped the balance. The most likely culprit was the sun itself. Stars like ours grow brighter as they age, slowly increasing the energy they deliver to their planets. As the young sun warmed, Venus began to absorb more heat than its oceans could handle. Water evaporated faster than it could be returned by rainfall. This increase in water vapor intensified the greenhouse effect, trapping even more heat and driving further evaporation. It was the beginning of a runaway cycle. Oceans that once may have stretched across the surface boiled away, leaving behind steam-filled skies. Water vapor, in turn, was broken apart by ultraviolet radiation from the sun. The lighter hydrogen escaped into space, while the heavier oxygen either reacted with surface rocks or drifted away. Over time, Venus lost its hydrogen, and with it the ability to sustain water. What remained was a dry world with no oceans to absorb carbon dioxide, and no way to prevent greenhouse gases from accumulating. The climate spun out of control. Carbon dioxide filled the atmosphere, pressure soared, and the planet was transformed into the inferno we see today. Evidence of this lost water lingers in the atmosphere. Scientists have measured an unusually high ratio of deuterium, a heavy form of hydrogen, compared to ordinary hydrogen. This enrichment suggests that large amounts of lighter hydrogen escaped over time, consistent with the loss of vast amounts of water. It is as though Venus still carries a chemical scar, a fingerprint of oceans long gone. The idea that Venus might once have been more Earth-like carries profound implications. If life ever had a chance to arise there, even briefly, it would mean that two planets in the same solar system both fostered biology, if only for a while. We may never know if microbes swam in ancient Venusian seas, but the possibility is enough to expand our perspective. Life, it seems, might not be a rare accident, but a natural outcome whenever conditions are right. Venus, even in its failure, may hint at how common life could be across the universe. At the same time, Venus reminds us how fragile habitability is. Small differences in orbit and feedback can make the difference between a planet of oceans and a planet of fire. Earth has the advantage of just the right distance from the sun, an atmosphere moderated by plate tectonics, and a biosphere that helps regulate carbon dioxide. Venus lacked some of these stabilizers, and once it began to warm, it had no way to stop the spiral. In planetary terms, the divergence between Earth and Venus may have been narrow, but the outcomes could not be more different. There is a poetic sadness in imagining Venus as a lost paradise. While Earth blossomed with forests, oceans, and creatures, Venus scorched itself into sterility. From afar, both planets still shine with brilliance, but only one remains alive. Some scientists even call Venus a failed Earth, a planet that started with the same ingredients but ended with a different recipe. This failure is not meaningless, it is instructive. By studying how Venus lost its water, we learn how planets maintain or lose their habitability. That knowledge may one day help us protect our own world. The puzzle of Venus's past also feeds into the search for exoplanets. Many worlds discovered around other stars are close to their suns, receiving more heat than Earth does. Without knowing Venus's story, we might be tempted to consider them potential Earths. But with Venus as a guide, we recognize the warning signs. A planet in the so-called habitable zone may not be habitable if it cannot keep its water. Venus is the cautionary example, a bright beacon in our sky that says, "Beware, distance is not everything." If we could somehow peer back in time to the Venus of billions of years ago, the view might be astonishing. Imagine seas glimmering under a dimmer sun, clouds drifting across a blue sky, rain falling on volcanic plains, perhaps rivers carved valleys, and perhaps shallow seas lapped against rugged coasts. It is a vision that feels both familiar and alien, a twin Earth that could have been. That world is gone, erased by heat and pressure. But the thought of it lingers every time we look at the bright morning star. Today, when we see Venus in the dawn or dusk sky, we are seeing both the present and a ghost of the past. We see the brilliant planet it has become, a furnace of acid clouds and lava plains, but we also glimpse in imagination the world it might once have been. The puzzle of Venus's past is not just a scientific question. It is a meditation on fragility, on the narrow line that separates paradise from inferno. Earth was lucky. Venus was not. And in that difference lies a lesson that speaks not only of our neighbour's fate, but of our own responsibility to safeguard the balance of our living world. If you could somehow stand on the surface of Venus, shielded by impossible technology that kept you alive against the heat and pressure, the first thing you might notice is not what you see, but what you hear. Sound on Venus would be unlike sound on Earth. The air is so dense, more than 90 times heavier than our own atmosphere, that it would carry vibrations differently. Voices, if spoken, would sound deeper and slower, as though the air itself were pressing on every syllable. A clap of the hands would not ring sharply, but would travel as a muffled thump, stretched and distorted by the weight of carbon dioxide. The atmosphere would act like an enormous filter, muting high frequencies and amplifying the low. It would be less a crisp world of sharp sounds and more a realm of bass tones, heavy and lingering. Yet, for all the strangeness of the acoustics, there would be little to hear. Venus is not a place of bustling noise. There are no birds to sing, no rivers to flow, no winds to whistle past your ears at ground level. The surface winds are sluggish, moving at only a few kilometers per hour, and in such dense air they would barely rustle anything at all. Instead of rustling leaves or shifting sands, you might hear only the faint, constant hum of the atmosphere itself, a low drone of pressure filling every gap. The world beneath the clouds would be eerily silent, a silence not of emptiness but of suppression, as though every sound was smothered before it had the chance to bloom. The Soviet Venera landers, which survived for brief minutes to hours on the surface, did capture audio data. What they recorded was not dramatic thunderclaps or volcanic explosions, but the subdued whisper of wind moving across the barren plains. It was not silence, but it was close. The sound resembled a background hum, the kind you might hear when pressing your ear against a seashell, except here the shell is an entire planet wrapped in thick air. To imagine standing there is to imagine existing inside a perpetual hush, interrupted only by the weight of the atmosphere pressing on your eardrums. Beneath this silence, however, Venus is not geologically dead. Evidence points to seismic activity, the slow shifting of crust and mantle that sometimes rattles the ground. Without plate tectonics, Venus does not quake in the same way as Earth, but stresses build in its thick crust and release through faults, fractures and volcanic eruptions. Instruments aboard orbiters have detected signals that may be Venus quakes, tremors that shake the ground beneath the crushing sky. On Earth, quakes can rumble through cities, toppling buildings and sending aftershocks. On Venus, there are no cities, no forests, no oceans to amplify the shaking. A quake would ripple through the stone, heard perhaps as a deep vibration, but the dense atmosphere would dampen any roar. The silence would remain, interrupted only by a low, rolling tremor that quickly vanished back into stillness. Volcanism adds another layer to this hidden soundtrack. The radar eyes of the Magellan mission revealed countless volcanic structures, some of which may still be active today. Recent studies suggest that eruptions could be ongoing, releasing bursts of sulfur dioxide into the atmosphere. If you stood nearby, what would such an eruption sound like? On Earth, volcanoes roar, hiss, and crack as lava explodes into the air. On Venus, the dense atmosphere would muffle these sounds, turning them into heavy booms and dull rumbles. The hiss of gas might be swallowed entirely, leaving only the deeper tones to roll through the thick air. Instead of dramatic fireworks, it would be a muted performance, as though nature itself were whispering its violence. The paradox is striking. A planet alive with pressure, heat, and geological unrest presents itself on the surface as nearly silent. The environment conspires to smother sound, to push everything into a low register, to erase sharpness and clarity. The surface would be a place where sound travels faster than on Earth, about twice as quickly, but carries less character. Each vibration would be flattened, drawn out, and swallowed by the weight of the atmosphere. It is an acoustic world that feels heavy not just on the body but on the ears. And then there is the silence of absence. On Earth, even in remote places, there is always some sound. The chirp of insects, the rustle of trees, the distant crash of waves. On Venus, there are no signs of life to fill the silence, no leaves to tremble, no animals to stir, no rainfall to patter on stone. The silence is total not because sound cannot exist, but because nothing lives to make it. It is a silence of desolation, as if the planet itself has chosen to keep its voice hidden. This stillness is perhaps the most haunting aspect of Venus. A planet that blazes like a beacon in our sky is, up close, a world of muted tones and swallowed echoes. Imagine looking across a plain of cracked rock under a golden haze, the horizon blurred by the thickness of the air. You listen for something, a gust, a rustle, a crack. But all you hear is your own breath, distorted and deepened by the density of the air in your suit. Even the sun is silent, reduced to a pale smudge in the sky. The only true voice belongs to the occasional whisper of wind, so faint you wonder if you imagined it. And yet, hidden beneath that quiet, the planet still stirs. Quakes ripple through its crust, eruptions may still break the surface, and the atmosphere itself is alive with lightning far above. It is a reminder that silence does not mean stillness. Venus is not a dead world, only a world where its activity is muffled, hidden beneath its veil of air. The silence is not absence, but concealment, a mask drawn tight over a body that is still restless. For planetary scientists, studying these hidden sounds and silences is more than an exercise in imagination. It helps us understand how atmospheres shape perception, how geology persists without tectonics, and how planets express their inner workings. On Venus, those expressions are quieted, but they are still there, waiting to be teased out by careful instruments and clever analysis. The strange acoustics, the muted quakes, the eerie hush of the surface, all of it paints a portrait of a world that is as fascinating in its silence as in its fury. So when you see Venus shining brightly in the twilight sky, consider that beneath its brilliance lies a world wrapped in quiet, a world where sound bends low, where eruptions are whispers, and where silence reigns not because nothing happens, but because everything is subdued. Venus is not only a planet of fire and pressure, it is also a planet of silence, a reminder that even in the cosmos, the loudest places can sometimes be the quietest to the ear. After decades of relative neglect, Venus is once again drawing the gaze of space agencies around the world. For years it stood in the shadows of Mars, which attracted the lion's share of robotic explorers, rovers, and orbiters. But now, a new wave of missions is preparing to return to our sister planet, armed with technologies capable of answering questions that have lingered for generations. NASA, the European Space Agency, and others are lining up spacecraft with names as poetic as their ambitions: Da Vinci, Veritas, and Envision. Together they promise to transform our view of Venus from a half-understood enigma into a world as richly mapped and studied as any in the solar system. The Da Vinci mission, short for Deep Atmosphere Venus Investigation of Noble Gases, Chemistry and Imaging, is perhaps the most daring of the group. Scheduled to launch in the late 2020s, it aims to plunge directly into the thick atmosphere of Venus. Carried aboard a descent probe, instruments will sample the gases layer by layer, analysing their composition with exquisite detail. For the first time in decades, we will measure directly the chemical makeup of the planet's air, tracing noble gases, water vapour, and isotopes that hold clues about Venus's origin and evolution. As the probe falls, It will also capture stunning images of the surface through gaps in the clouds, particularly of the mysterious Tessera terrain. These ancient highlands may hold the keys to understanding how Venus's crust formed and why it differs so dramatically from Earth's. Da Vinci will not survive long once it reaches the surface. No probe has ever lasted more than a couple of hours under Venus's crushing pressure and searing heat. But those final minutes could be some of the most valuable in planetary science. Even a short-lived glimpse from the ground, combined with atmospheric sampling during the descent, would provide a treasure trove of information. If Earth and Venus truly began as twins, then the chemical fingerprints uncovered by Da Vinci may explain why their paths diverge so completely. Did Venus ever hold oceans? Did its atmosphere once resemble our own? How did it lose its water and transform into the inferno we see today? Where Da Vinci focuses on the air, Veritas, short for Venus emissivity, radio science, INSAR, topography and spectroscopy, turns its eyes to the ground. This NASA mission, also expected to launch late in the 2020s, will orbit Venus with advanced radar capable of producing maps far sharper than those from the Magellan spacecraft of the 1990s. Veritas will chart surface features with unprecedented precision, revealing the contours of mountains, volcanoes, and plains down to scales never before seen. It will also probe the planet's geology by measuring how heat radiates from different materials, distinguishing between rock types and searching for signs of fresh lava flows. The central question Veritas hopes to answer is whether Venus is still geologically active today. The discovery of recent volcanism would be a game-changer, proving that the planet is not just a relic of ancient activity, but a living world, still reshaping itself beneath its veil of clouds. If eruptions are occurring now, they could explain puzzling variations in atmospheric sulfur dioxide, and perhaps even shed light on the global climate of the planet. Beyond that, Veritas will help us understand why Venus lacks plate tectonics, and how its crustal processes differ so radically from Earth's. Joining Veritas in orbit will be the European Space Agency's Envision mission. Building on the legacy of Magellan and Venus Express, Envision will combine radar mapping with atmospheric studies, offering a complementary view of the planet. Its instruments will zoom in on volcanic structures, fault systems, and tesserae, piecing together the geological history of Venus with fresh clarity. Envision will also probe the connection between surface and atmosphere, tracing how volcanic outgassing might shape the clouds above. By comparing data from both NASA and ESA missions, scientists hope to create a holistic picture of Venus's present state and its evolutionary journey. The return to Venus is not simply about filling a gap in our planetary catalogue. It is driven by profound scientific questions that touch on Earth's own story. How do planets of similar size and composition end up with such different fates? Why did Earth remain habitable while Venus became a furnace? What does this tell us about the boundaries of habitability around other stars? Venus is the closest natural experiment we have, a control case that helps us understand what makes Earth unique and what might await planets elsewhere in the universe. There is also a practical urgency to the renewed interest. As humanity grapples with climate change, Venus offers a sobering example of how greenhouse effects can transform a planet. Though Earth is nowhere near Venus's extreme, the physics of heat-trapping gases is universal. By studying how carbon dioxide behaves in thick atmospheres, we refine the models that help us predict our own future. In this sense, exploring Venus is not just about curiosity. It is about perspective, about holding a mirror up to our planet and seeing what could have been, or what might one day be if balance is lost. Beyond the science, the romance of Venus continues to inspire. There is a peculiar beauty in the idea of probing a world that gleams so brightly in our skies, yet hides so stubbornly behind its clouds. Each mission that dares to pierce the veil carries with it a sense of unveiling a cosmic secret. We imagine the descent of Da Vinci's probe, falling through golden clouds, measuring the air with every kilometre. We picture Veritas orbiting above, sending radar pulses that reveal volcanoes stretching across plains of lava. We envision stitching together these discoveries into a grand story of fire, air, and time. Perhaps this renewed focus is also a kind of redemption. For centuries, Venus was imagined as a paradise, a twin Earth waiting to be discovered. When probes revealed its true nature as a furnace of acid clouds and crushing pressure, interest waned, as though disappointment had dulled our curiosity. Now, however, the story has shifted. Venus is no longer seen as a failed Earth, but as a vital piece of the planetary puzzle. Its extremes are not deterrents. They are invitations to understand how planets work, how they thrive, and how they collapse. In the coming decades, as these missions unfold, we may finally answer some of the questions that have lingered since the first probes fell silent on the surface. We may learn if Venus is still volcanically alive, if its tesserae hold clues to ancient oceans, and if its atmosphere carries whispers of its long-lost past. Each discovery will not only deepen our knowledge of Venus, but also enrich our understanding of Earth, reminding us that our planet's balance is precious and rare. When you see Venus shining at dawn or dusk, remember that it is more than just a bright point in the sky. It is a world waiting to share its secrets, and for the first time in a generation, we are sending emissaries to listen. The Da Vinci probe, the Veritas radar, the Envision orbiter, together they represent a chorus of curiosity aimed at Earth's twin. In their data will be the echoes of ancient oceans, the traces of volcanic fire, and the lessons of a climate that spun out of control. Venus is calling again, and humanity is finally preparing to answer. To understand Venus, it helps to see it not in isolation but in contrast with its neighbours. The solar system is like a family of worlds, each shaped from the same primordial dust, yet each with its own character. Venus sits between Mercury and Earth, with Mars not far beyond, and together these four terrestrial planets form a set of siblings, whose differences are as revealing as their similarities. By comparing them, we can see just how unusual Venus really is, and why its story matters not only for our corner of the cosmos, but for distant worlds orbiting other stars. Mercury is the smallest of the group, a scorched rock spinning closest to the Sun. With almost no atmosphere to speak of, it is exposed to the full blast of solar radiation. Daytime temperatures soar high enough to melt lead, while nighttime plunges into deep freeze colder than Antarctica. It is a world of extremes, shaped by the absence of air and water. Venus, though only slightly farther from the Sun, could hardly be more different. Where Mercury is bare and airless, Venus is smothered in an atmosphere so thick it erases day-night contrasts and creates a climate of unrelenting uniformity. Both planets are hot, but for entirely different reasons. Mercury, because it cannot hold its heat, and Venus because it cannot let its heat escape. Side by side, they illustrate the importance of atmosphere in shaping planetary destiny. Earth, by contrast, is the success story. Roughly the same size and mass as Venus, it might have followed a similar path. Instead, Earth's oceans and plate tectonics acted as stabilizers, cycling carbon dioxide between air, water, and rock, preventing the greenhouse effect from running wild. Life itself joined the act, drawing down carbon, exhaling oxygen, and adding balance to the system. Earth shows what happens when conditions align to create a self-sustaining equilibrium. Venus, meanwhile, shows what happens when those same balances tip. Two planets of nearly equal promise evolved into paradise and furnace, reminding us that habitability is not a guarantee but a delicate balance. Then there is Mars, smaller and colder, a world of deserts and canyons. Once, Mars may have been warmer and wetter, with rivers, lakes, and perhaps even a shallow ocean. But with less mass than Earth or Venus, Mars could not hold on to its atmosphere. Over time, solar winds stripped it bare. leaving only a thin shell of carbon dioxide. What remains is a planet where liquid water cannot last on the surface, a reminder that planetary fate can also be determined by size. Too small, and a planet cannot hold its air. Too close to the sun, and a planet may lose its oceans. In this light, Venus and Mars are opposites, one suffocated by an atmosphere too heavy, the other left barren by one too thin. Earth, once again, sits in the middle, with just the right balance to sustain life. The uniqueness of Venus lies in how it combined the worst of both extremes. Like Mars, it may once have had oceans, but unlike Mars, it was close enough to the sun for those oceans to vanish in steam. Like Mercury, it is searingly hot, but unlike Mercury, the heat is not from exposure, but from entrapment. Its rotation is peculiar, spinning backwards and slowly, unlike any of its siblings. Its geology is active, but in a way unlike Earth's, with vast volcanoes and coronae formed without plate tectonics. Venus shows that even small shifts in conditions, a little more sunlight, a little less water, a different crustal behavior, can lead to wildly different outcomes. Looking outward, this lesson becomes even more powerful. When astronomers discover rocky exoplanets, many of them turn out to be similar in size to Earth and Venus. Some orbit close to their stars, in positions that might allow liquid water if the balance is right. Without knowing Venus, we might too easily call them Earth-like. But Venus reminds us that size and distance are not enough. Two planets of equal mass in similar orbits can diverge into worlds that are nothing alike. To interpret distant exoplanets, we must understand Venus in detail, so that we can tell whether we are looking at another potential Earth, or another hidden inferno. The irony is that Venus, long called Earth's twin, is less like Earth than any of its terrestrial siblings. Mercury, though airless, shares a rocky simplicity. Mars, though smaller, shares valleys, volcanoes, and hints of water. Earth, of course, is the closest match in size and mass. But Venus has gone so far down a unique evolutionary path that it feels almost alien compared to them all. It is the twin that grew up differently, shaped not by what it had, but by what it lost. In losing its oceans, it lost its chance at balance, and in losing balance, it lost the path to habitability. Still, Venus plays a crucial role in understanding the diversity of planets. Without it, we might imagine that Earth's balance is typical. We might assume that most rocky planets find themselves with mild climates and liquid water. Venus corrects that assumption, showing that planets can and do become hostile, even when they start with the same raw ingredients. Mars adds another warning. Even if water flows, size and atmosphere matter. Mercury adds yet another. Proximity and airlessness create their own extremes. Together, these four worlds form a spectrum, and Venus sits at the point where habitability tips into hell. For exoplanet research, this spectrum is invaluable. Astronomers now speak not just of the habitable zone around stars, but also of the Venus zone, the region where planets are more likely to become too hot and too greenhouse-dominated to support life. Knowing where that boundary lies helps refine our search for true Earth analogues. When telescopes capture spectra of exoplanet atmospheres, they will look for signs of water, carbon dioxide, and clouds, and it will be the lessons of Venus that tell us whether we're seeing signs of life or signs of a runaway greenhouse. And yet, for all its hostility, Venus still shines as one of the brightest points in our sky. It continues to inspire myths, poems, and questions, just as it did for ancient civilizations. The contrast between its beauty above and its brutality below is not a contradiction. It is a reminder. Planets are not what they appear to be from afar. They are shaped by fragile balances, unique histories, and small differences that magnify into great outcomes. So when Venus is compared to Mercury, Mars, and Earth, it stands apart not only for what it is, but for what it teaches. Mercury shows us the cost of having no air. Mars shows us the cost of losing it. Earth shows us the reward of balance. And Venus shows us what happens when balance tips the other way. Taken together, they are not just worlds in orbit, but chapters in a grand planetary story, a story that echoes as we look to distant stars. And in that story, Venus is the chapter that warns us, challenges us, and fascinates us most of all. A reminder that a twin can look familiar, yet live a life entirely its own. Venus has always been more than just a planet in our sky. For thousands of years it has been a mirror, reflecting our own hopes, fears, and desires. From the moment people began to name the bright light that shone at dawn and dusk, it became entwined with our sense of beauty and our longing for the heavens. The Romans called it the goddess of love. The Greeks imagined Aphrodite rising from the sea foam. The Maya tracked it as a celestial force tied to war and power. In every culture, Venus has carried meaning, not simply because it is bright, but because it is inescapable. Wherever you stand on Earth, the morning and evening star is there, commanding attention, whispering mystery. That symbolism of love and beauty persists, but now it is layered with another truth. When science finally revealed what lies beneath the glow, Venus was not the lush paradise so many once imagined. It was a furnace, a world of acid clouds, lead-melting heat and crushing air. The goddess of love, it turns out, also wears the mask of danger. In that irony lies a deeper reflection of humanity. We often find that what looks beautiful from afar hides complexities up close. We are drawn to brightness, but brightness is not always safety. Venus reminds us that beauty and danger can coexist, sometimes inseparably, and that our judgments of the cosmos and of ourselves are often based on appearances that can deceive. Human curiosity thrives on such paradoxes. When Venus turned out to be hostile, it did not end our fascination. Instead, it intensified it. We wanted to know why this twin of Earth became so different, why two planets born together could walk such separate paths. The challenge of Venus's hostility made it all the more compelling. Soviet landers dared to descend through its furnace, knowing they would survive only minutes. NASA sent Magellan to peel back the clouds with radar, revealing volcanoes and plains hidden for eons. Soon, Da Vinci and Veritas will return, plunging again into that mystery. Each mission is not only about studying a planet, but about answering something within ourselves, the drive to explore even when the outcome is harsh, even when the beauty masks fire. In this way, Venus becomes a symbol of resilience. Every attempt to study it has been a struggle against odds. Probes crushed, melted, silenced within minutes. Yet we persist. Each scrap of data, each blurry image, each reading of wind and pressure has been enough to keep us going back. Humanity's story with Venus is not one of easy victories, but of perseverance in the face of adversity. In that struggle we see ourselves, fragile beings, curious beings, determined beings, confronting a universe that is often indifferent to our survival. But Venus also teaches us fragility. It shows how thin the line is between habitability and catastrophe. A little closer to the sun, a little less water, a little less ability to recycle carbon, and a planet can tip from potential paradise to permanent inferno. When we compare Earth with Venus, we see how precarious our own balance truly is. The oceans, the forests, the atmosphere, all of it works in delicate harmony. Break that harmony, and the shift may be irreversible. Venus whispers to us that worlds can change, not in ways that suit us, but in ways that erase possibility. It is a mirror of what happens when balance is lost, a reminder that our own resilience must be matched by care. There is also humility in its lesson. Venus glows brighter than any star in the night sky, yet for centuries we misunderstood it. We imagine oceans, jungles, swamps, even civilizations beneath the clouds. Only when we sent probes did we learn the truth. The gap between imagination and reality was vast, and the correction was humbling. Venus shows us that the universe is under no obligation to meet our expectations. What we see is not always what is. The bright evening star turned out to be an oven. If we are to understand the cosmos, we must be willing to confront such surprises, not with disappointment, but with curiosity. And perhaps this is why Venus remains so captivating. It embodies both sides of the human experience, the yearning for beauty and the confrontation with truth, the dream of paradise and the reality of fire, the courage to persist and the humility to accept limits. In its brilliance, we see hope. In its heat, we see warning. In its history, we see possibility. And in its future, we see the continuation of our own restless journey to understand. To gaze at Venus is to see a reflection of our dual nature. We are drawn to beauty but live with danger. We imagine paradise but must face reality. We are fragile but resilient, capable of faltering, yet equally capable of trying again. Venus is not only Earth's twin in size, it is a twin in symbolism, carrying our own contradictions back to us. A goddess of love that hides a furnace, a planet of brilliance that conceals silence, a place of allure that teaches caution. So when the evening star rises tonight, bright against the fading sky, take a moment to see it not just as a planet, but as a mirror. In its glow lies the story of humanity's curiosity, our persistence, and our fragility. Venus shines because it reflects sunlight, but it also shines because it reflects us, our dreams, our questions, our determination to keep reaching for the unknown, even when the unknown is wrapped in clouds of fire. Venus has always been there, a steadfast light in the sky, rising before dawn or gleaming at twilight. Generations of people have looked to it, long before they knew it was a planet, long before science revealed the world beneath its clouds. To shepherds, sailors, poets, and astronomers alike, Venus was a companion of beginnings and endings, the morning star that heralds the sun, or the evening star that lingers after it. Unlike many celestial objects that fade or wander unpredictably, Venus has remained constant, an eternal presence tracing a graceful dance across the heavens. It is this constancy that has given it such power in human culture. The same light that guided ancient navigators across seas still shines today above modern cities. The same star that inspired hymns and myths continues to rise on schedule, indifferent to the passing of empires. In an ever-changing world, Venus has been unchanging, a bright reminder that while human lives come and go, the cosmos endures. When you see Venus glowing low on the horizon, you are seeing the same sight your ancestors did thousands of years ago. This same glow that they wove into stories of gods, goddesses, and celestial cycles. Yet, the irony lies in how different the surface of Venus is from its serene appearance. The morning star looks peaceful, but beneath its veil it is a place of crushing air, endless heat, and acid skies. It shines as a beacon of beauty, but its reality is stark and inhospitable. This duality has always been part of its allure. Venus reminds us that appearances can deceive, that the brightest star in the sky can hide the harshest truths. And in that, it offers a quiet warning, not only about planets, but about life itself. What we see from afar may not be the full story. To truly understand, we must look deeper. Venus has been both a muse and a teacher. From myth to science, it has mirrored humanity's imagination and curiosity. It showed us that planets can be alike in size, yet worlds apart in fate. It taught us about greenhouse effects, about geology without plate tectonics, about atmospheres that circulate faster than the ground beneath them. It forced us to think about how fragile Earth's own balance is, and how easily habitability can slip away. To study Venus is not only to learn about another world, but to see our own more clearly. And still, despite everything we know, the acid clouds, the volcanoes, the crushing air, it remains a thing of beauty. Its light has not dimmed with knowledge. If anything, it has grown richer. Now, when we look at Venus, we do not just see a bright star. We see an entire story. The fiery surface, the mysterious past, the the daring probes that braved its atmosphere, the maps made by radar, the dreams of floating cities above its clouds. Its glow is layered with history, myth, and science, each adding depth to the simple joy of watching it rise. Perhaps that is Venus's greatest gift. It reminds us that mystery and knowledge are not opposites, but partners. The more we discover, the more wonder grows. Knowing the truth does not strip away the poetry, it deepens it. To gaze at Venus now is to feel awe not only for its beauty, but for the fact that we can know so much about a world so different from our own. We can admire it as the morning star while also imagining the lava plains and sulfur skies that lie beneath. Its brilliance in the sky becomes a symbol of the human capacity to see beyond appearances, to peel back veils, to turn mystery into understanding without losing the sense of wonder. And so, Venus endures as the eternal morning star. It is the planet that greets us at dawn, the light that lingers at dusk, the companion of humanity's sky-watching journey from ancient myth to modern science. It is beauty wrapped in danger, warning wrapped in brilliance, a paradox that captures both the fragility of worlds and the resilience of curiosity. Long after we are gone, Venus will still rise, untroubled, carrying its golden glow across the heavens. Future generations will look to it, just as the ancients did, and wonder what lies behind the veil. In the end, Venus is more than a planet. It is a reflection of our own longing to understand, a reminder that the cosmos is vast and full of surprises, and a symbol of the balance between beauty and truth. As the eternal morning star, it shines not only with sunlight but with meaning, guiding us to look upward, to dream, and to never stop asking questions. Venus has always been with us, watching from the edges of night and day, a faithful companion in the sky. It gleams brighter than any star, rising before the sun or lingering after it, a jewel hung in the heavens that has inspired myths, poems, and questions for as long as people have looked upward. To the eye, it is pure beauty, steady, luminous, eternal. And yet, when we peel back the veil of clouds and step, if only in imagination, onto its surface, we find a world so unlike its appearance that it feels almost like a cosmic trick. Venus, Earth's twin in size and composition, is at the same time Earth's shadow, a planet that reveals what can happen when balance is lost. In many ways, Venus is a mirror of contrasts. From afar it is the brightest wanderer in the sky, but beneath its thick blanket of clouds lies a landscape no human could survive. Its surface is hotter than any kitchen oven, hot enough to melt lead. Its atmosphere presses down with 90 times the weight of Earth's air, and its skies are filled with droplets of sulfuric acid. Where Earth has oceans, Venus has lava plains. Where Earth has winds that carry cloud gently across the sky, Venus has gales that race around the planet at hurricane speeds. It is a place of fire disguised as a star of love, a goddess cloaked in acid and stone. And yet the beauty remains. The morning star and the evening star have not lost their radiance, even as science stripped away the illusions of paradise. If anything, knowing the truth makes the sight of Venus even more extraordinary. When we see it shining at dusk, we're not just looking at a dot of light. We're looking at a world that is alive with extremes, a world that has challenged spacecraft and humbled expectations. That tiny spark of brilliance carries with it stories of volcanic mountains taller than Everest, plains the size of continents, clouds that glow faintly in ultraviolet light, and storms that roar endlessly around the globe. Venus is, in every sense, Earth's twisted twin. Born from the same materials in the same nursery of the early solar system, it should have been a world much like ours, and for a time it may have been. Some models suggest that Venus once had oceans, perhaps shallow seas that reflected a dimmer sun. If so, it may even have been habitable for millions of years. But its closeness to the sun, combined with a runaway greenhouse effect, sent it down another path. Its oceans boiled away, its air thickened, and the balance tipped toward a permanent furnace. Two planets born as siblings became opposites, one green and blue, the other yellow and red. This duality makes Venus more than just a scientific curiosity. It is also a warning. It shows us how fragile planetary climates can be, how easily conditions can shift from balance to catastrophe. On Earth, oceans, plate tectonics, and life itself have helped maintain a climate where water remains liquid and ecosystems flourish. On Venus, without those stabilizers, the climate ran away, locking the planet into an unbreakable cycle of heat. When we think about our own atmosphere, our own balance, we cannot help but reflect on the lesson Venus offers. It is not that Earth will become Venus, it will not, but that even small changes in chemistry and energy can change everything. Venus is a reminder that resilience must be cherished and balance must be guarded. But beyond the warning, Venus also offers inspiration. Every mission to its surface has been an act of courage. Soviet landers endured conditions harsher than any spacecraft had faced before, surviving only for minutes but sending back priceless glimpses of an alien landscape. NASA's Magellan revealed mountains, valleys, and volcanoes hidden beneath the clouds, turning guesswork into detailed maps. Future missions like Da Vinci, Veritas, and Envision will go even further, diving once again into the atmosphere and scanning the surface with sharper eyes. The persistence with which humanity keeps returning to Venus speaks to our own nature. We do not turn away from difficulty. We lean into it. Even when the odds are against us, even when probes are doomed to melt and fail, we go anyway because curiosity demands it. Venus also broadens our imagination beyond our solar system. As astronomers discover planets around other stars, many of them look suspiciously like Venus, rocky, Earth-sized and orbiting close to their suns. Without Venus as our guide, we might mistake them for potential Earths, but with Venus in mind, we see the difference. We recognize the signs of a runaway greenhouse, the hints of thick atmospheres and cloud veils, the danger of drawing conclusions too quickly. Venus, in its extremity, helps us sift through the cosmos, distinguishing between worlds that might host life and those that have already closed the door. And still, Venus remains a paradox. It is both beauty and danger, both inspiration and warning. It is a place of silence, where sound is swallowed by dense air, yet also a place alive with storms and quakes beneath its veil. It is a planet that appears constant in our sky, but has lived through dramatic changes in its past. It is a goddess of love wrapped around a furnace, a mirror that reflects both the promise and the fragility of worlds. Perhaps that is why Venus feels so timeless. Every culture that has ever looked up has woven it into stories, and every age of science has reimagined it with new tools. Its role is not finished, because it continues to rise in the morning and shine in the evening, inviting us to look, to wonder, and to learn. Long after our own lives are forgotten, Venus will still be there, gleaming above the horizon, a reminder of beauty, mystery, and the thin line between paradise and fire. So as this journey closes, take one last lingering thought of the morning star. Remember it not only as a light in the sky, but as a world of extremes, a twin that diverged, a mirror that reflects both danger and resilience. In its glow, we see both what we are and what we might one day face. Venus is eternal in our skies, eternal in our imagination, and eternal in the lessons it offers. A twisted twin, a warning and a wonder, shining always the eternal morning star.